Hello there and welcome to Science for Sleep, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're setting off on a journey unlike any humanity has ever taken. Not a voyage across an ocean, not a mission to the moon, not even a daring expedition to Mars. Instead, we're going to imagine something far more ambitious. A ship so large that it functions as a tiny world. A journey so long that the people who begin it will never see its end. A destination so distant that entire generations will live and die while travelling toward it. It's called a generation ship, and if humanity ever hopes to settle another star system without discovering faster-than-light travel, it may be the only way. But before we drift into the darkness between the stars, I'd love to know where in the world you're listening from tonight, and perhaps even more fittingly, if you could leave Earth forever and board a ship destined for another star, would you go? It's an easy question to answer quickly. It's a much harder question to answer honestly. If you find these quiet journeys through science relaxing, interesting, or simply a pleasant way to unwind at the end of a long day, I'd be grateful if you liked the video and subscribed. It helps this little corner of calm continue growing, and it allows more curious travellers to join us on these late-night adventures. Now, settle in somewhere comfortable, let your thoughts slow down, and together, let's leave Earth behind. Because somewhere far beyond the planets, beyond the comets, beyond the edge of the solar system itself, lies one of the strangest questions humanity has ever asked. How long could a generation ship really survive in deep space? To begin answering that question, we first need to appreciate just how enormous space truly is. People often talk about travelling to another star as if it's simply the next logical step after Mars. After all, we've already sent spacecraft to every major planet. We've landed humans on the moon. We've built robots that roam other worlds. Surely another star can't be that much farther away. Unfortunately, the universe has a habit of humbling our optimism. Consider the closest star beyond our Sun. Its name is Proxima Centauri. At first glance, it sounds encouragingly nearby. Astronomers call it our nearest stellar neighbour. Neighbour is a comforting word. Neighbours live next door. Neighbours borrow sugar. Neighbours occasionally mow their lawn at inconvenient hours. Proxima Centauri, however, is approximately 4.24 light-years away. That means its light takes over 4 years to reach us despite travelling at nearly 300,000 kilometres per second. Even saying the number doesn't fully communicate its scale. Imagine boarding a commercial airliner. Now imagine flying continuously without stopping. No vacations, no delays, no lost luggage, no crying babies in the seat behind you. At typical airline speeds, reaching Proxima Centauri would take roughly 6 million years. By the time you arrived, human civilization might have transformed beyond recognition several times over. Entire species appear and disappear on shorter timescales. This presents a rather awkward problem. Humans don't live 6 million years. Most of us are doing well if we manage 80 or 90. Even with advanced medicine, reaching a few hundred years would be a remarkable achievement. The stars, meanwhile, remain stubbornly far away. Science fiction often solves this problem by introducing faster-than-light engines, warp drives, hyperspace, jump gates, convenient buttons labelled "go dramatically faster than physics allows." The trouble is that none of those technologies currently exist, and many physicists suspect they may never exist. The laws of nature appear to place strict limits on how fast information and matter can travel. Light speed seems to be the cosmic speed limit. Nature's version of a very stern traffic officer. As far as we know, there are no shortcuts, no hidden tunnels, no secret express lanes, just distance. Lots and lots of distance. So if we cannot make the journey shorter, perhaps we must make the travellers last longer. This idea leads us directly to the concept of a generation ship. A generation ship is exactly what it sounds like. A spacecraft designed not for one crew, but for many generations of people. The first passengers would board knowing they would never reach the destination. Their children might not reach it either, nor their grandchildren. perhaps not even their great-grandchildren. The journey itself would become a way of life. People would be born aboard the ship, grow up aboard the ship, raise families aboard the ship, grow old aboard the ship, and eventually pass away aboard the ship. All while the vessel continued silently crossing the darkness between stars. When most people picture space travel, they imagine astronauts, a small crew, a mission lasting months or years, a carefully planned expedition with a clear beginning and end. Generation ships require a completely different way of thinking. The ship isn't merely transportation. The ship becomes civilization. Imagine being born aboard such a vessel. You have never seen Earth. You have never felt wind against your face. You have never watched clouds drift across a blue sky. You've never walked through a forest. You've never stood beside an ocean. Every experience you've ever had occurred inside an artificial environment, constructed centuries earlier by people you've never met. Earth exists for you only as history, a place described in books, a distant origin story. Perhaps no more emotionally real than ancient Rome feels to many people today. In fact, after enough generations, Earth might begin to seem almost mythical. Children born aboard the vessel would hear stories about a world covered in vast oceans and forests. They might learn about birds and rainstorms and mountains, yet they would never experience any of those things firsthand. To them, Earth could feel less like a home and more like a legend, something that existed long ago before the great journey began. This raises an interesting question. Would future generations even care about reaching the destination? Think about it for a moment. The original passengers might have spent years preparing for departure. They would understand the mission. They would remember the reasons. Perhaps Earth faced environmental collapse. Perhaps resources became scarce. Perhaps humanity simply wanted to explore. Whatever the motivation, the founders would possess a powerful sense of purpose. Their descendants might not. A child born 200 years into the voyage did not choose the mission. They never saw the departure. They never knew Earth. The destination might feel abstract and distant, something future generations worry about. Much like retirement feels to a teenager, this challenge alone is enough to keep sociologists awake at night. How do you maintain a shared goal across centuries? How do you ensure people continue supporting a mission that began long before they existed? Human history offers some clues. We often assume modern civilization operates on short timescales, yet many projects have spanned generations. Medieval cathedrals sometimes required hundreds of years to complete. The workers who laid the foundations knew they would never see the finished structure. Still, they continued. They trusted future generations to carry on the work. Generation ships would demand an even greater version of that commitment. Not merely decades, not centuries, potentially millennia. And unlike a cathedral, the ship would be moving constantly through one of the most hostile environments imaginable. Because despite how peaceful space often appears in documentaries, deep space is not friendly. It's not actively trying to kill you. It doesn't need to. The vacuum handles that part perfectly well on its own. Space contains no breathable air, no atmospheric pressure, no natural protection from radiation, no convenient repair shops, no roadside assistance, no chance of pulling over for directions if something goes wrong. Imagine your car breaking down halfway between cities. Now, imagine the nearest help is 4 light-years away. Suddenly your extended warranty seems less important. A generation ship must carry everything required for survival. Every drop of water, every breath of air, every piece of food, every spare part, every medical supply, every tool, every machine, everything. The ship cannot depend on regular resupply missions. Earth would be too far away. Even communication becomes difficult over interstellar distances. A message sent to Proxima Centauri takes more than 4 years to arrive. A reply requires another 4 years. Asking Mission Control for help could take nearly a decade, and that's assuming Mission Control still exists. A civilization capable of launching generation ships may change dramatically over centuries. Governments rise and fall, languages evolve, cultures transform. The people receiving your message might live in a world almost unrecognizable compared to the one that launched you. This means the ship must become self-sufficient, not partially self-sufficient, completely self-sufficient. It must function as an independent ecosystem, a tiny artificial world floating through endless darkness. That idea sounds exciting, and it is, but it's also extraordinarily difficult. Even Earth struggles with sustainability. Our planet possesses vast oceans, forests, ecosystems, and countless species interacting in complex ways. Despite all those advantages, maintaining environmental balance isn't always easy. Now imagine shrinking an entire world into a spacecraft. Every system becomes critical, every resource matters, every mistake accumulates. A small leak that seems insignificant today could become a catastrophe decades later. A minor engineering flaw might not reveal itself until several generations have passed. Unlike cities on Earth, the ship cannot expand outward. There is no outside, no frontier, no new territory waiting to be developed. The entire world exists within the vessel's walls. This limitation changes how people think. On Earth, many societies solved resource shortages by expanding. They explored new lands, discovered new resources, established new settlements. A generation ship has nowhere to expand. Its population, resources, and environment must remain carefully balanced. Too many people create shortages. Too few people create different problems. Maintaining stability becomes an ongoing challenge. And yet, despite all these obstacles, scientists have seriously studied the concept. Not because they expect construction to begin next week, but because generation ships may represent one of the few approaches that doesn't require breaking known laws of physics. The idea has fascinated researchers for decades. Some proposed enormous rotating habitats. Others envisioned hollow cylinders several kilometers long. Many designs include artificial gravity generated through rotation. The ship slowly spins, pressing people against the inner surface. To those living inside, it would feel remarkably similar to gravity. Walk toward one side, and the floor stays beneath your feet. Drop an object, and it falls normally. Life continues, at least on the surface. Yet even with artificial gravity, residents would know they lived somewhere unusual. Look upward, and you might see homes, farms, and parks curving overhead. The landscape itself would wrap around the interior, a reminder that your entire world is contained within a machine crossing the stars. For some people, that thought feels inspiring. For others, slightly unsettling. Perhaps both reactions are reasonable. After all, humans evolved beneath open skies. We spent hundreds of thousands of years surrounded by natural environments. Our ancestors watched seasons change, observed sunrise and sunset, experienced weather. A generation ship would need to recreate enough of those experiences to support human well-being. Not because they're strictly necessary for survival, because they're necessary for happiness. And survival alone may not be enough. Humans need purpose, community, beauty, entertainment, meaning. A successful generation ship must support not only bodies but minds. People aren't machines. You cannot simply provide oxygen and calories and expect civilization to thrive indefinitely. A ship carrying thousands of individuals across centuries must become a place worth living in. A home rather than a prison. A society rather than a transport container. The more scientists examine these questions, the more fascinating they become. Because designing a generation ship ultimately forces us to ask a deeper question. What exactly does a human civilization need in order to endure? Not for years, not for decades, but for centuries spent alone in the darkness between stars. And once we start examining the practical realities of building such a world, we quickly discover that the greatest challenge may not be propulsion at all. Instead, it may be something far more ordinary. something every living thing depends upon every single day: air to breathe, water to drink, food to eat. The basic ingredients of survival that seem abundant on Earth, but become precious beyond imagination when your entire civilization exists inside a single vessel millions of kilometers from anywhere else. Several thousand years ago, your entire world could fit within the distance you could walk in a few days. A river over the next hill might be unknown territory. A mountain range could feel like the edge of existence. For most of human history, the idea of travelling even a few hundred kilometres was a major undertaking. Journeys were measured in weeks, months, or occasionally years. People often lived and died within sight of the same landscape. Yet despite those limitations, humans kept pushing outward. They crossed deserts, they sailed oceans, they climbed mountains, and eventually they stepped onto another world. Tonight, I'd like you to imagine the next step in that story. Not a voyage lasting months, not a mission lasting decades, but a journey so vast that the travellers who begin it will never see its destination. Because if humanity ever attempts to reach another star using known physics, we may be forced to undertake the longest journey ever attempted. Not just the longest in human history, the longest journey any civilization has ever conceived. When people think about interstellar travel, they often imagine speed, faster engines, more powerful rockets, breakthrough technologies that shrink impossible distances into manageable trips. That instinct makes sense. Throughout history, transportation improved by becoming faster. Horses became trains, trains became automobiles, automobiles shared the world with aircraft. Aircraft shortened distances that once seemed enormous. Each advance made the planet feel smaller. Naturally, many assume the same pattern will continue among the stars. The trouble is that space is operating on scales that make Earth seem tiny. Even the fastest spacecraft humanity has ever built would require tens of thousands of years to reach nearby stars. Voyager 1, currently the most distant human-made object from Earth, has been travelling since 1977. For nearly half a century it has raced outward through the solar system. That sounds impressive, and it is. Yet if Voyager were aimed toward Proxima Centauri, our nearest stellar neighbour, it would still require roughly 70,000 years to arrive. 70,000 years. To put that into perspective, 70,000 years ago, modern humans were sharing the planet with other human species. Agriculture had not been invented. Cities did not exist. Writing had not appeared. The pyramids were unimaginably far in the future. Everything we call civilization today fits comfortably inside that time span. And yet a simple spacecraft travelling at Voyager's speed would still be making its way toward another star. This is where many conversations about interstellar travel come to an abrupt halt. The distances appear so absurd that the entire idea feels hopeless. Why even discuss journeys that take tens of thousands of years? Why imagine missions that no individual could ever complete? The answer reveals something important about humanity. We are remarkably stubborn. Throughout history, people repeatedly attempted things that seemed impossible at first. Crossing oceans once appeared reckless. Flying through the air sounded absurd. Reaching the moon looked unattainable. Each generation inherits limits from the one before it. Some limits remain permanent, others eventually fall. The challenge is figuring out which is which. At the moment, faster-than-light travel belongs firmly in the realm of speculation. Scientists have explored countless ideas: warp drives, wormholes, exotic space-time geometries. Many of these concepts are fascinating. Some emerge naturally from mathematical models. A few remain active areas of research, yet none have moved beyond theory. No laboratory has demonstrated a functioning warp drive. No spacecraft has folded space like a sheet of paper. No engineer has built a wormhole in a garage. As far as current evidence suggests, light speed remains the ultimate limit. That doesn't mean interstellar travel is impossible. It simply changes the nature of the problem. Instead of asking how fast we can travel, we begin asking how long we can survive, and those are very different questions. Imagine a civilization determined to reach another star. Their scientists run the calculations, their engineers study propulsion systems, their economists examine resources. Eventually, someone in a meeting quietly points out a difficult truth. The trip may take centuries. Silence follows, because centuries change everything. A spacecraft carrying a crew for 5 years is a vehicle. A spacecraft carrying people for 500 years becomes something else entirely. It becomes a world. This realization is what gave birth to the concept of the generation ship. Rather than trying to shorten the voyage, humanity accepts its length. The journey becomes a multi-generational project. People are born aboard, people live aboard, people die aboard. The mission continues. At first glance, the idea feels strange, perhaps even unsettling. After all, most of us view transportation as temporary. You board a plane because you intend to arrive somewhere. You enter a train because you're going elsewhere. Transportation is usually the space between places. A generation ship erases that distinction. The ship is both transportation and destination simultaneously. For most residents, it is simply home. Imagine speaking with a child born 300 years into the voyage. Ask them where they're from. They won't say Earth. They've never seen Earth. Their parents never saw Earth. Their grandparents never saw Earth. Earth belongs to history. The ship is their homeland. The corridors are their streets. The agricultural sectors are their countryside. The habitat rings are their neighbourhoods. The vessel itself becomes a civilization. That shift in perspective changes everything. Because now the question isn't merely whether a spacecraft can survive. The question becomes whether a society can survive. History suggests that maintaining stable societies for long periods is surprisingly difficult. Human civilizations change constantly. Languages evolve. Governments rise and fall. Beliefs transform. Cultures blend and separate. Even relatively stable societies experience enormous changes over centuries. Consider someone living in London 500 years ago. The city existed. The people existed. Yet almost every aspect of daily life differed dramatically. Language sounded different. Technology was different. Politics were different. Medicine was different. Education was different. Their world would feel strangely familiar and completely alien at the same time. Now imagine those same changes occurring aboard a generation ship. The original founders establish rules. Future generations modify them. New traditions emerge. Old traditions fade. Customs adapt to circumstances nobody anticipated. After several centuries, the descendants of the founders may view the mission very differently than their ancestors did. This possibility has fascinated sociologists for decades. Some researchers worry about mission drift, the gradual loss of commitment to the original goal. Others argue that new cultures would naturally emerge, and that's perfectly acceptable. After all, civilizations are supposed to evolve. The challenge lies in ensuring evolution doesn't threaten survival. Because unlike Earth, a generation ship offers very little margin for error. If a society on Earth experiences political instability, neighbouring nations still exist. Trade routes remain possible. External assistance can arrive. Resources may be imported. A generation ship has none of those advantages. Every problem must be solved internally. Every conflict occurs within a closed environment. Every mistake affects everyone. The isolation is absolute. In many ways, the closest comparison isn't a nation, it's an island. Throughout history, isolated islands have provided fascinating examples of how human societies adapt when separated from the wider world. Some flourished, others struggled. Many developed unique customs and identities over time. Yet even the most isolated island still existed beneath Earth's sky. A generation ship faces a deeper level of separation. There are no neighbouring islands, no passing ships, no possibility of rescue, only the vast darkness between stars. Curiously, That darkness itself presents an unusual psychological challenge. Space often appears busy in science fiction. Ships darting everywhere, stations orbiting planets, constant communication. Frequent encounters, reality looks rather different. Interstellar space is mostly empty. A generation ship might spend centuries travelling through regions where nothing visible changes. No planets pass nearby. No stars noticeably grow larger. No landmarks appear. The same distant constellations remain overhead for generations. A person could live their entire life aboard the ship without witnessing any dramatic external event. The universe outside would seem almost frozen. This creates an interesting contrast. Inside the vessel, life continues normally. Children grow up, people fall in love, families form, technology evolves, culture changes, entire lifetimes unfold. Outside, the stars barely move. The ship carries a rapidly changing civilization through an environment that appears almost timeless. Perhaps the strangest aspect of all is how the mission transforms our understanding of success. Most journeys have clear outcomes. You either arrive or you don't. Generation ships blur that distinction. Imagine being one of the original passengers. You know with certainty that you will never reach the destination. Success cannot mean arrival. Instead, success becomes something else. Your task is not to finish the mission. Your task is to preserve the mission. You become a caretaker of the future, a steward responsible for handing the journey to the next generation, and then they hand it to the next, and then the next. It's a remarkable idea when you think about it. Every person contributes to a goal they will never personally experience. Modern society occasionally asks similar things of us. We plant trees whose shade we'll never enjoy. We build infrastructure that lasts beyond our lifetimes. We conduct scientific research whose benefits may emerge decades later. Generation ships simply extend that principle to an unprecedented scale. The destination becomes a gift from ancestors to descendants, a promise carried across centuries. Of course, promises alone don't keep people alive. Sooner or later, practical realities take over. A civilization travelling between stars must eat. It must breathe. It must drink, and that's where the dream encounters its first major obstacle, because surviving for a few months in space is difficult. Surviving for a few years is harder. Surviving for centuries demands something humanity has never fully achieved before, a completely closed ecosystem. On Earth, it's easy to forget how dependent we are on our planet's natural systems. Forests recycle carbon dioxide, oceans regulate climate, microorganisms process waste. Countless species participate in cycles that keep life functioning. Most of the time, these processes operate quietly in the background. We barely notice them. A generation ship cannot afford that luxury. Every breath must be accounted for. Every drop of water matters. Every calorie has to come from somewhere. There is no outside environment waiting to correct mistakes. The ship must become its own miniature Earth, not merely for one crew, not merely for one lifetime, for hundreds of years, perhaps longer. And that's where the true scale of the challenge begins to emerge. The greatest obstacle may not be propulsion, it may not be radiation, it may not even be distance. Instead, it may be the simple question of whether a tiny artificial world can successfully recycle the essentials of life forever. Suppose for a moment that humanity finally makes the decision. After centuries of speculation, debate, and ambitious plans, the arguments are over. The funding has been approved. The technology has advanced far enough. The destination has been chosen. A generation ship is going to be built. Not a prototype, not a small experimental habitat orbiting Earth. An actual interstellar vessel intended to carry human beings across the darkness between stars. At first, this sounds like an engineering problem: build a bigger spacecraft, add stronger engines, install larger life support systems, problem solved. But the moment scientists begin calculating what such a vessel would actually require, something unusual happens. The spacecraft starts becoming less like a machine and more like a world. Because a normal spacecraft only needs to survive for a mission. A generation ship must survive for centuries, and that changes absolutely everything. Think about the oldest building you've ever seen. Perhaps it's a medieval cathedral, a castle, an ancient temple, maybe a stone bridge that has stood for hundreds of years. Now imagine living inside that structure continuously while it travels through space. Imagine every wall, every pipe, every electrical cable, every computer system, every door, every air filter, and every water pump needing to remain functional not for decades, but for generation after generation. Suddenly, building a spacecraft begins to look less like engineering and more like civilization design. Modern technology is surprisingly temporary. That might sound strange because we often think of our machines as durable. Yet most things humans build have relatively short lifespans. Cars might last 20 years. Commercial aircraft often serve for a few decades. Computers become outdated within years. Even large buildings require constant maintenance. Now imagine asking any of those systems to remain operational for 400 years, or 600, or 1,000. The challenge becomes extraordinary. A generation ship cannot depend on replacement parts arriving from Earth. There are no supply chains, no cargo deliveries, no manufacturers waiting to ship new equipment. Every component that fails must either be repaired, rebuilt, or replaced using resources already aboard the vessel. In effect, the ship must contain its own industrial civilization, not just homes and farms, factories, workshops, machine tools, manufacturing equipment, everything required to keep the world running. Consider something as simple as a metal bolt. On Earth, if a bolt breaks, replacing it is trivial. A nearby factory can produce millions of identical bolts. A generation ship cannot assume that luxury. Every replacement part must either be stored in advance or manufactured aboard the vessel. That means future generations must preserve not only physical tools but also knowledge. The ability to make things becomes just as important as the things themselves. This realization leads to a fascinating question. What is the minimum amount of civilization required to sustain civilization? It's not enough to bring food. You must bring agriculture. It's not enough to bring medicine. You must bring the ability to produce medicine. It's not enough to bring machines. You must bring the capability to build new machines. Slowly, the spacecraft expands in complexity. What began as a vehicle starts resembling a miniature planet. The comparison to Earth becomes increasingly important. Our planet possesses a remarkable advantage. It's self-repairing. Forests regrow, rivers continue flowing, ecosystems adapt. Countless biological processes operate automatically. Human civilization benefits from billions of years of natural infrastructure. Generation ships inherit none of that. Everything must be deliberately engineered. Every cycle must be maintained. Every resource must be managed. Nothing happens automatically. This raises another important issue: size. Most science fiction movies portray enormous interstellar vessels because giant ships look impressive on screen. But there is a practical reason why real generation ships may need to be enormous. Small systems are fragile. Large systems are resilient. Imagine a tiny fish tank. A small change in temperature can quickly become dangerous. A minor contamination event can affect everything. Now compare that to an ocean. The ocean absorbs disturbances far more effectively because of its scale. Generation ships face similar challenges. Tiny ecosystems can become unstable. Larger ecosystems provide buffers against disaster. A larger population also improves survival prospects. This is where mathematics enters the conversation. Scientists studying generation ships often calculate minimum population sizes needed to maintain genetic diversity. The numbers vary depending on assumptions. Some estimates suggest a few hundred carefully managed individuals. Others recommend thousands. Some researchers argue for populations exceeding 10,000. The reason is simple. Human populations require diversity. Small groups face increased risks from genetic bottlenecks. Over many generations, maintaining healthy genetic variation becomes increasingly important. As a result, many proposed generation ships resemble floating cities rather than traditional spacecraft. Entire communities would live aboard. Schools, hospitals, recreation areas, residential districts, agricultural zones, industrial sectors, perhaps even parks. The idea may sound extravagant until you remember that people will spend their entire lives there. No one wants to spend 80 years inside a cramped metal corridor. Psychology matters. A civilization expected to survive centuries needs spaces where people actually enjoy living. This lesson appears repeatedly throughout human history. When environments become unpleasant, social problems often follow. Crowding creates stress. Isolation creates stress. Monotony creates stress. Generation ship designers must account for all of them. Imagine growing up without ever experiencing weather. No rain, no snow, no breeze, no changing seasons. Every day occurs inside a controlled environment. At first, that might sound convenient. No storms, no floods, no hurricanes. Yet humans evolved in dynamic environments. We respond emotionally to changing landscapes. Many researchers believe future generation ships would deliberately incorporate artificial seasons. Not because crops require them, because people might require them. Residents may experience changing temperatures, lighting conditions, and environmental patterns designed to mimic Earth's natural cycles. Spring arrives, summer follows, autumn appears, winter returns. Not because nature demands it, because human psychology expects it. Even the concept of day and night becomes an engineering decision. In deep space, there is no natural sunrise, no natural sunset. The ship determines what time means. Artificial lighting systems would likely create daily cycles. Lights brighten gradually each morning, dim slowly each evening. People wake, work, socialize, and sleep according to schedules created by designers centuries earlier. It's an odd thought. Future generations may experience entire lifetimes guided by artificial suns. Children might grow up believing sunrise is simply what happens when ceiling lights slowly brighten each morning. The more you think about it, the stranger it becomes. Almost every aspect of life that Earth provides naturally must be recreated artificially. Gravity, daylight, weather, agriculture, water cycles, even open space. Many generation ship concepts include large communal areas specifically designed to prevent feelings of confinement. Perhaps artificial lakes, small forests, wide-open gathering spaces, not because they're strictly necessary for survival, because they help people feel human. This distinction becomes increasingly important. Engineering can keep bodies alive. Creating a successful civilization requires much more. For example, consider education. The original builders possessed technical knowledge necessary for maintaining the vessel. Future generations must learn that knowledge, and then teach it again, and again, and again. A generation ship creates one of the longest educational projects in human history. Imagine trying to preserve critical information for 500 years. Now imagine preserving it while society evolves continuously. Languages change, cultural values shift, political systems adapt, yet certain knowledge must survive intact. People must continue understanding how life support systems function, how manufacturing works, how medical technologies operate, how agriculture is maintained. Failure isn't merely inconvenient. Failure threatens the survival of everyone aboard. Throughout history, human civilizations have occasionally lost important knowledge. Ancient technologies disappeared. Techniques vanished. Languages became unreadable. Skills faded over time. A generation ship cannot afford such losses. The consequences would be immediate. As a result, preserving knowledge becomes almost as important as preserving food or water. Some researchers have even suggested specialized educational institutions dedicated entirely to maintaining critical technical expertise. Future generations might treat certain professions with enormous respect. Engineers, agricultural specialists, medical personnel, system maintenance experts, not because of social status, because their work literally keeps civilization alive. Interestingly, this could reshape culture itself. On Earth, societies often develop around abundant resources. Generation ships develop around limited resources. Every resident understands that survival depends on cooperation. Waste becomes visible. Consequences become immediate. People cannot simply ignore environmental realities. The walls of the ship constantly remind everyone that resources are finite. In some ways, generation ships may become the most environmentally conscious societies in human history. Not necessarily because residents are morally superior, because reality leaves them little choice. Every kilogram matters, every litre matters, every decision matters. Yet despite all these precautions, one uncomfortable fact remains. Things break, machines fail, unexpected events occur. Even the best designed systems encounter problems. Consider the International Space Station. It is one of the most impressive engineering achievements ever created. Yet, it requires constant maintenance. Astronauts regularly replace components, repair equipment, address unexpected issues, and that's with continuous support from Earth. Generation ships must handle everything independently. A problem occurring 3 centuries into the voyage cannot be referred back to the original builders. They're long gone. Future residents become responsible for solving challenges nobody anticipated. In a way, that's reassuring. Human beings are remarkably adaptable. Throughout history, we have survived in deserts, rainforests, mountains, tundra, and islands. We build solutions, we improvise, we innovate. Generation ships would likely develop their own unique forms of creativity. New traditions, new technologies, new approaches to old problems. The descendants of the original passengers may eventually understand aspects of ship life far better than the founders ever did. After all, they would have spent generations refining the system, living inside it, learning from it, improving it. What begins as a spacecraft might gradually evolve into something entirely new, a civilization specifically adapted for life between stars, and perhaps that's the most remarkable aspect of the entire concept. Generation ships aren't merely about transportation, they're about creating a sustainable human world from scratch, a place capable of surviving independently for centuries, a world that carries its own atmosphere, its own agriculture, its own industry, its own culture, and its own future. Take a slow breath and imagine something that most of us rarely think about. The air around you right now. Not the weather, not the temperature, just the air itself. Every breath arrives so effortlessly that it's almost invisible to our attention. You inhale. Oxygen enters your lungs, carbon dioxide leaves. The process repeats thousands of times every day without requiring a single conscious thought. Now imagine that every breath you will ever take for the rest of your life must come from a machine. Not just your breaths, the breaths of your children, your grandchildren, their children, and every generation that follows. Suddenly air becomes very interesting, because once humanity commits to a generation ship, the challenge is no longer simply reaching another star. The challenge is keeping an entire civilization alive long enough to get there. And civilization, as it turns out, runs on 3 deceptively simple ingredients: air, water, food. On Earth, we tend to think of these things as resources. On a generation ship, they become something closer to sacred infrastructure. Every aspect of survival depends on them. Every system connects back to them. And if any one of them fails, nothing else matters. It is often said that humans can survive about 3 minutes without air. 3 days without water, and 3 weeks without food. The exact numbers vary depending on circumstances, but the principle remains useful. Air comes first, water comes second, food comes third. A generation ship must provide all three continuously for centuries, not most of the time, not 99% of the time, all of the time. Imagine a city with 10,000 residents. Now imagine that city floating alone between stars. Every breath those people take removes oxygen from the atmosphere and adds carbon dioxide. On Earth, plants help manage that exchange. Forests absorb carbon dioxide. Oceans participate in complex chemical cycles. Countless natural processes contribute to maintaining atmospheric balance. A generation ship must recreate those functions artificially. At first glance, the problem seems manageable. After all, astronauts already survive aboard spacecraft. The International Space Station has supported human crews for decades. Surely we already know how to provide air in space, and in a sense we do. The trouble is scale. The International Space Station typically houses a handful of astronauts. A generation ship may contain thousands of people. The ISS receives regular resupply missions. A generation ship receives none. The ISS is supported by engineers, scientists, manufacturers, and entire nations back on Earth. A generation ship must support itself. These differences transform a difficult engineering challenge into an entirely different category of problem. Current spacecraft life support systems rely heavily on recycling. Carbon dioxide is removed from cabin air. Oxygen is regenerated. Water is recovered. Every possible resource is conserved. Engineers become remarkably inventive when launching supplies into orbit costs millions of dollars. Even so, modern systems remain imperfect. Some losses occur. Some replacement materials are required. For a voyage lasting months, this is acceptable. For a voyage lasting centuries, even tiny losses become dangerous. Imagine losing just 1% of a critical resource every year. 1% sounds trivial, barely noticeable. Yet after enough time, the consequences become enormous. Generation ships therefore require recycling systems approaching near perfection. Almost everything must be reused. Almost nothing can be wasted. The phrase throwing something away loses its meaning. There is no away. Every object remains inside the system forever. This idea feels strange because Earth gives us the illusion of limitless disposal. Waste disappears into landfills, sewers, incinerators, distant locations we rarely think about. A generation ship exposes the truth hidden beneath that illusion. Waste never truly disappears. It simply changes form. Future interstellar societies would likely understand this reality far better than we do. Every piece of organic material becomes valuable. Every molecule matters. Human waste becomes fertilizer. Plant waste becomes compost. Food scraps become resources. The goal is not disposal. The goal is transformation. Everything cycles. Everything returns. Everything serves another purpose. In some respects, a generation ship begins to resemble a giant ecosystem rather than a machine. And that brings us naturally to water. Water may be the most astonishing substance aboard the vessel. Consider the glass of water sitting beside someone listening tonight. Some of those molecules may have passed through dinosaurs. Others may have existed in glaciers thousands of years ago. The water cycle on Earth constantly recycles the same molecules. Rain falls, rivers flow, oceans evaporate, clouds form. The cycle continues endlessly. A generation ship must build its own miniature version of that cycle. The water you drink today may eventually become water someone drinks centuries later. That statement sounds slightly unsettling until you realize it is already true on Earth. The difference is visibility. A closed system makes the process impossible to ignore. Every drop must be recovered. Every leak becomes significant. Every purification system becomes essential. Scientists have already explored these concepts through experiments on Earth. One famous example was Biosphere 2, constructed in Arizona during the early 1990s. The goal was ambitious. Researchers attempted to create a sealed artificial ecosystem capable of sustaining human life. The project taught scientists many valuable lessons, some encouraging, others less so. Unexpected problems emerged. Oxygen levels fluctuated. Ecological balances shifted. Certain species thrived while others struggled. Maintaining a stable, closed environment proved far more difficult than anticipated. And that's on Earth, with gravity, with abundant sunlight, with emergency assistance available if necessary. A generation ship would face even greater challenges. Nature turns out to be extraordinarily complicated. Every ecosystem contains countless interactions. Microorganisms affect soil quality, insects influence plant reproduction, bacteria participate in nutrient cycles. Tiny changes can produce surprisingly large consequences. Engineers designing generation ships therefore face an uncomfortable choice. Should they create simple ecosystems that are easier to control, or complex ecosystems that are more resilient? Simple systems offer predictability. Complex systems offer stability. The ideal balance remains an active area of research. And then we arrive at food. Food may appear straightforward. Grow crops, harvest crops, feed people, problem solved. Reality is considerably more complicated. Human beings require a diverse diet. Calories alone are not enough. We need proteins, fats, vitamins, minerals. A long list of nutrients working together in precise ways. A generation ship must provide all of them indefinitely. Furthermore, food serves purposes beyond nutrition. Meals are cultural events, social experiences, sources of comfort and identity. Imagine eating exactly the same meals every day for your entire life. Then imagine your children doing the same, and their children. Eventually, variety becomes important not merely for health, but for morale. Future ship designers may therefore cultivate surprisingly diverse agricultural systems, vegetables, fruits, grains, legumes, perhaps even carefully managed livestock. Every option comes with trade-offs. Animals provide useful food products but consume resources. Plants require less energy but may limit dietary variety. Different societies aboard different ships might make different choices. Some vessels may become largely vegetarian. Others may develop sophisticated artificial food technologies. Still, others may combine multiple approaches. One particularly intriguing possibility involves cultured meat. Instead of raising entire animals, future technology may allow meat to be grown directly from cells. The process already exists today in its early forms. Centuries from now, it may become routine. Future residents might enjoy hamburgers produced without ever raising a cow. From their perspective, traditional livestock farming could seem as antiquated as horse-drawn carriages appear to many people today. Of course, agriculture itself presents major challenges. Plants require light, water, nutrients, space. Earth receives enormous amounts of energy from the sun every second. Generation ships must either capture energy efficiently or generate it internally. This requirement shapes the entire vessel. Agricultural systems consume significant resources. Lighting alone may require vast amounts of power. Some designs propose enormous greenhouse sections illuminated by artificial sunlight. Others explore advanced farming techniques, hydroponics, aeroponics, vertical agriculture, methods that maximize productivity while minimizing resource consumption. Interestingly, future farming may look very different from traditional agriculture. No tractors crossing open fields, no weather forecasts, no droughts, no unexpected frost. Conditions become carefully controlled. Temperature, humidity, lighting, nutrient delivery, everything optimized. Future farmers might spend more time monitoring computer systems than walking through fields. Yet despite all the technology involved, the basic purpose remains unchanged: growing food to sustain human life. Some things stay surprisingly constant even among the stars. There is also another challenge that receives less attention: taste. Humans are remarkably emotional about food. Meals connect us to family, culture, memory, and tradition. A generation ship carrying thousands of people from diverse backgrounds must somehow preserve culinary variety. Recipes become cultural artifacts. Cooking techniques become heritage. Future generations may treasure ancient food traditions inherited from Earth. Perhaps descendants hundreds of years into the voyage still prepare versions of dishes their ancestors brought aboard, modified, adapted, evolved, yet still recognizable. Food may become one of the strongest links connecting future generations to humanity's origins. This cultural role matters because survival involves more than biology. People need reasons to enjoy life. A successful generation ship cannot merely keep residents alive. It must create a society worth living in. That distinction appears repeatedly whenever scientists seriously examine long-duration space settlements. Technical survival is difficult. Meaningful survival is harder. A civilization sustained entirely by machinery must avoid becoming psychologically sterile. Residents need beauty, community, tradition, celebration, and food often sits at the centre of all those experiences. The more we examine air, water, and food, the more a generation ship resembles a living organism. Air circulates like respiration, water cycles like blood, agriculture functions like metabolism. Everything connects, everything depends upon everything else. A failure in one system eventually affects all the others. This interconnectedness creates both strength and vulnerability. Strength because resources are continuously recycled. Vulnerability because disruptions can spread throughout the entire system. Imagine a disease affecting a major crop. Imagine contamination entering a water supply. Imagine a critical recycling system malfunctioning. Each problem requires immediate attention. There is no neighbouring city to request assistance from. No external ecosystem waiting to compensate. The ship must solve its own problems. This reality may fundamentally shape the culture aboard. Future residents would likely develop an unusually strong awareness of ecological relationships. Children might grow up understanding resource cycles as naturally as modern children understand roads and buildings. Environmental literacy could become as essential as reading and mathematics. After all, every resident lives inside a closed system they can never leave. The consequences of ecological mistakes become impossible to ignore. Perhaps that's one of the most fascinating aspects of generation ships. They force humanity to confront realities that Earth often allows us to overlook. Nothing is truly disposable. Everything comes from somewhere. Everything goes somewhere. Every resource exists within a larger cycle. A generation ship simply makes those truths visible. Imagine for a moment that the ship has finally settled into its journey. The engines, whatever form they take, continue their patient work. The life support systems hum quietly in the background. The farms produce food. The water cycles endlessly through purification systems. The air remains breathable. Year after year passes without major incident. Then a decade passes. Then another. The children who boarded alongside their parents become adults. New children are born. The original passengers begin to grow old. And somewhere along the way, humanity encounters a challenge unlike any it has faced before. Not a mechanical challenge, not an engineering challenge, a biological challenge. Because a generation ship is not merely carrying people through space, it is carrying the future of an entire population, and populations are complicated things. When most of us think about survival, we imagine individuals. Can one person survive? Can one family survive? Can one crew survive? Generation ships force us to think on a completely different scale. Can a civilization survive? Can a human population remain healthy for hundreds of years while completely isolated from the rest of humanity? The answer is not as simple as many people assume. At first glance, the problem seems straightforward. Just send enough people. 1,000 people sounds like a lot. 10,000 sounds even better. Surely somewhere within those numbers the issue solves itself. Unfortunately, biology rarely rewards optimism quite so easily. Every population carries genetic information. That information is constantly being shuffled and passed from one generation to the next. The larger the population, the greater the genetic diversity tends to be. The smaller the population, the greater the risk that harmful traits become concentrated over time. This is one reason isolated populations on Earth have sometimes experienced genetic problems. When a small group remains separated from a larger population for many generations, diversity gradually declines. Certain genes become more common, others disappear entirely. The process can happen slowly enough that people barely notice it at first. Generation ships must prevent that outcome. The descendants arriving at another star hundreds of years later need to remain healthy, strong, adaptable, capable of thriving in whatever environment awaits them. That requirement has led scientists to spend decades studying a surprisingly difficult question. How many humans are actually needed to sustain a healthy population? The answer depends on who you ask. Some studies suggest a few hundred individuals might be enough under carefully managed conditions. Others recommend several thousand. Some researchers argue that anything smaller than that introduces unacceptable risks. Part of the difficulty comes from the fact that humanity has never attempted anything remotely similar. No civilization has ever voluntarily isolated itself from the rest of the species for centuries. There are examples of isolated communities, remote islands, small settlements, groups separated by geography, but none of them existed inside a completely closed environment crossing interstellar space. Generation ships occupy entirely new territory. Because population size affects far more than genetics, it affects society itself. Imagine a ship carrying only a few hundred people. The vessel could be smaller. Resource consumption would decrease. Life support requirements would become more manageable. Yet new problems immediately appear. A small population has fewer specialists, fewer scientists, fewer engineers, fewer doctors, fewer teachers. The loss of even a handful of skilled individuals could significantly affect the community. A larger population provides resilience, more diversity, more expertise, more opportunities for innovation. But larger populations require larger ships, more food, more water, more energy. Everything becomes more complex. Generation ship designers therefore find themselves balancing competing priorities. Too few people creates one set of dangers, too many creates another. Somewhere in between lies a population capable of enduring centuries. Finding that number remains one of the most fascinating questions in interstellar planning. Yet genetics represents only part of the challenge. The moment people begin having children aboard the ship, another reality emerges. The mission changes. For the original passengers, the voyage is a decision. For their children, it is simply life. That distinction matters enormously. Imagine being born aboard a generation ship. You never chose the journey. You never attended the launch ceremony. You never stood beneath Earth's sky. You never walked through a forest or watched waves crash against a shoreline. Everything you've ever known exists inside the vessel, the corridors, the residential districts, the agricultural sectors, the communal spaces. That is your world. Earth belongs to history books. The destination belongs to the future. The present belongs to the ship. This creates a fascinating psychological shift. The founders view the vessel as transportation. Their descendants may view it as home. After enough generations, some residents might struggle to understand why anyone would want to leave. Think about that for a moment. The original mission focuses entirely on arrival. Future generations may feel differently. They could develop emotional attachments to the ship itself. Entire cultures might emerge centered around life aboard the vessel. Children often define normality based on whatever surrounds them growing up. A person raised inside a generation ship may find the idea of open skies surprisingly unsettling. After all, humans generally prefer familiar environments. The unknown can be intimidating. To someone born among the stars, a planetary surface might seem every bit as strange as deep space appears to us. This possibility has fascinated sociologists and psychologists for years. How would culture evolve aboard a generation ship? No one knows for certain, but history provides some clues. Human cultures constantly adapt to their environments. Mountain communities develop different traditions than coastal communities. Desert societies develop different traditions than forest societies. The environment shapes behaviour. Behaviour shapes culture. Culture shapes identity. Generation ships would likely produce entirely new cultural forms. Perhaps new holidays emerge. Maybe the anniversary of departure becomes a major celebration. Perhaps children learn stories about Earth much the way modern children learn stories about ancient civilizations. Some traditions survive, others evolve. Still others disappear entirely. Language itself may change. This process happens naturally on Earth. Languages constantly evolve. Words appear. Words vanish. Meanings shift. Given enough time, descendants aboard a generation ship might speak noticeably differently than their ancestors did. Not because anyone planned it, because that's what languages do. Now extend that process across 300 years, 500 years, 1,000 years. The results become difficult to predict. Future residents might retain strong cultural connections to Earth, or they may develop entirely new identities. Perhaps both happen simultaneously. History suggests human beings are remarkably good at maintaining connections to the past while creating something new. Then there is the question of reproduction itself. On Earth, population growth often occurs naturally. Generation ships cannot afford such spontaneity. Resources are finite. Space is finite. Everything must remain balanced. Too many births strain resources. Too few births create population decline. Future societies aboard generation ships may therefore regulate population size very carefully. That idea can sound uncomfortable to modern ears, yet the logic is difficult to escape. A closed environment requires careful planning. Imagine a ship designed to support 10,000 people. If the population suddenly doubles, every system faces additional stress. Food production, water recycling, housing, education, healthcare, everything. Conversely, if the population declines significantly, different problems emerge. Fewer workers, reduced genetic diversity, shrinking expertise. Maintaining balance becomes essential. Future generations may therefore treat population management much the same way modern societies treat infrastructure planning. Not as a controversial topic, as a practical necessity. Interestingly, this could influence family structures. Different communities may develop different approaches. Some might emphasize larger families, others might prefer smaller ones. Policies could evolve over centuries as circumstances change. The important point is that reproduction becomes more than a private matter. It becomes part of civilization's long-term survival strategy. There is also another factor that receives less attention. Accidents happen, disease happens, unexpected events happen. A population surviving for hundreds of years will inevitably encounter challenges. History demonstrates this repeatedly. Pandemics, natural disasters, political upheaval, economic crises. Human societies are constantly adapting to unforeseen circumstances. Generation ships will face their own versions of these challenges. The difference is isolation. Earth populations benefit from interaction. Knowledge spreads. Resources move. People migrate. Generation ships cannot rely on those mechanisms. Every problem must be addressed internally. This makes resilience extraordinarily important. The community must remain strong enough to absorb setbacks without collapsing. Fortunately, human beings possess a remarkable talent for adaptation. Our species has survived ice ages, volcanic eruptions, plagues, famines, wars, countless hardships across thousands of years. The descendants aboard generation ships would inherit that same adaptability. In fact, they might become exceptionally skilled at solving long-term problems. After all, their entire civilization depends on it. Consider education once again. Children born aboard the vessel would grow up understanding concepts that many people on Earth rarely consider. Resource cycles, ecological balance, system maintenance, interdependence. These ideas would be woven into daily life. Every resident would understand, at least intuitively, that their survival depends on cooperation. Few environments make interconnectedness more obvious than a generation ship. You cannot pretend someone else's actions don't affect you when everyone shares the same atmosphere, the same water supply, the same food systems, the same future. Over time, this reality may produce cultural values emphasizing responsibility and stewardship. Not because people become morally perfect. Human beings will remain human beings. Disagreements will still occur. Mistakes will still happen. Someone will probably still leave dirty dishes somewhere. Some traditions appear remarkably universal, but the shared understanding of dependence may become unusually strong. Everyone lives inside the same fragile world. Everyone contributes to maintaining it. Everyone benefits when it succeeds. Perhaps the most profound transformation concerns identity itself. For most of human history, people have identified with places, cities, regions, countries, continents. Generation ships introduce a new possibility, identity tied to a vessel, to a journey, to a civilization in motion. A person born 4 centuries into the voyage may not describe themselves as coming from Earth. They may describe themselves as belonging to the ship. The ship becomes homeland. History, society, future, everything wrapped together, and that may ultimately be the key to survival. Because a successful generation ship is not merely a collection of systems, not merely a habitat, not merely a vehicle. It is a living human society capable of sustaining itself across centuries, a place where children continue being born, where knowledge continues being passed forward, where culture continues evolving, where humanity continues existing despite the unimaginable distances separating it from its origins. Far above your head at this very moment, something is passing through you. Actually, not just one thing, trillions of things. Tiny particles born in distant stars, ancient supernova explosions, and some of the most energetic events in the universe are streaming through Earth constantly. Most of us never notice them. We walk to work, drink coffee, scroll through our phones, and go about our day completely unaware that space itself is raining invisible particles upon us every second. Fortunately, Earth is remarkably good at protecting us. Our atmosphere acts like a giant shield. Our magnetic field deflects enormous amounts of harmful radiation. The planet quietly absorbs cosmic punishment on our behalf. We rarely stop to appreciate just how valuable that protection is, but a generation ship crossing interstellar space would leave most of it behind. And once humanity ventures far from Earth's protective embrace, it encounters one of the greatest challenges of deep space survival. The universe is not empty. It only looks empty. This is one of the first misconceptions people develop about space. Films often portray it as a vast, peaceful vacuum, silent, still, harmless. The reality is far more complicated. Deep space is filled with invisible hazards, radiation, high-energy particles, microscopic debris, fields and forces that care absolutely nothing about human comfort. The darkness between stars may appear calm, but it is constantly in motion. And unlike storms on Earth, these dangers often arrive without warning. To understand why this matters, imagine standing outside during a rainstorm. Now imagine the raindrops are moving near the speed of light. That comparison isn't perfect, but it begins to capture the problem. One of the most significant threats comes from cosmic rays. Despite their name, cosmic rays are not really rays. They're mostly high-energy particles, protons, atomic nuclei, fragments of matter accelerated to extraordinary velocities. Some originate from exploding stars, others come from distant galaxies. A few possess energies so extreme that scientists still debate exactly how they were created. These particles travel across vast distances before colliding with whatever happens to be in their path, including spacecraft, including human bodies, including generation ships. On Earth, the atmosphere absorbs much of this radiation before it reaches us. The air above your head functions as a protective blanket, a very thick protective blanket. Deep space offers no such luxury. A generation ship would spend centuries exposed to an environment that life never evolved to endure. The effects accumulate slowly. That is what makes them particularly dangerous. Radiation is rarely dramatic. People often imagine glowing green energy beams or immediate catastrophe. Reality tends to be quieter. A particle passes through tissue. A cell is damaged. A strand of DNA is altered. Most of the time, the body repairs the damage. Sometimes it doesn't. Over years and decades, those risks add up. This concern already exists for astronauts today. Space agencies carefully monitor radiation exposure. Astronauts aboard the International Space Station receive significantly higher radiation doses than people on Earth. Yet even those missions typically last months, not centuries. Generation ships operate on an entirely different timescale. The question is no longer whether radiation exposure occurs. The question becomes how to manage it for generation after generation. Engineers have proposed several solutions. One approach involves shielding, lots of shielding. The simplest strategy is often the most effective. Put enough material between people and radiation. Water works surprisingly well. Hydrogen-rich materials work well. Certain metals help. The challenge is mass. Every kilogram added to a spacecraft must somehow be launched, accelerated, and carried across interstellar distances. Generation ships therefore face a balancing act. More shielding improves safety. More shielding also increases complexity. Some proposed designs place living areas deep within the vessel, surrounded by water tanks, agricultural zones, and storage compartments. The outer layers absorb much of the incoming radiation before it reaches residential areas. In effect, the ship wraps its population in protective layers, a tiny artificial world sheltered inside a larger machine. Interestingly, the very resources needed for survival may also provide protection. Water stores become radiation shields. Agricultural systems become barriers. Food reserves contribute to safety. The ship begins serving multiple functions simultaneously. Efficient design becomes essential, yet cosmic rays are only one part of the story. The sun itself presents another challenge. Most of us think of sunlight as pleasant, warm, comforting, associated with beaches and summer afternoons. The sun, however, occasionally behaves less like a friendly neighborhood star and more like a giant nuclear explosion happening continuously 150 million kilometers away. Every so often, it releases enormous bursts of charged particles. These events are called solar storms. Some are relatively minor, others are astonishingly powerful. In 1859, Earth experienced an event known as the Carrington event. Telegraph systems malfunctioned across the world. Operators received electric shocks. Some equipment continued operating even after being disconnected from power sources. If a similar event occurred today, modern technology could face significant disruption. Fortunately, Earth possesses both a magnetic field and an atmosphere. Generation ships travelling beyond the solar system would lose one of those protections entirely. Depending on their design, they may also lack the other. Future vessels might therefore include dedicated storm shelters, specialised protected areas where residents gather during periods of intense radiation activity. Imagine receiving an alert that a powerful burst of energetic particles is approaching. Families move toward heavily shielded sections of the ship. Schools pause classes, work temporarily stops. Life continues, but with precautions. Future generations may regard radiation alerts much the way we regard severe weather warnings today. Not pleasant, not unusual, simply part of life. Then there are micrometeoroids. The name sounds almost harmless. Tiny meteors, tiny problems. Unfortunately, velocity changes everything. Imagine throwing a grain of sand. Now imagine that same grain of sand travelling tens of kilometres per second. The object remains tiny. The energy becomes enormous. Interstellar space contains surprisingly little matter compared to Earth. Yet over centuries of travel, a generation ship covers tremendous distances. Eventually, encounters become inevitable. Most particles are microscopic. Many pose little threat. Some do. At sufficient speeds, even tiny impacts can damage equipment. Sensors, external structures, communication systems, protective surfaces. The ship must survive countless encounters over hundreds of years. This requirement influences engineering decisions. Future vessels may possess multiple layers of protection, outer shielding designed specifically to absorb impacts, sacrificial structures intended to take damage, repair systems prepared for gradual wear and tear. After all, a ship expected to survive centuries cannot remain pristine. The goal is resilience, not perfection. That distinction becomes increasingly important as the voyage continues. Earth teaches us something interesting about survival. Nothing lasts forever without maintenance. Roads require repair. Buildings require maintenance. Machines require replacement parts. A generation ship is no different. The difference is isolation. Every repair must occur internally. Every damaged component must be addressed by the people aboard. There is no calling a repair technician from another city. The nearest city may be several light years away. This reality transforms maintenance into a central feature of civilization. Future residents might spend considerable effort preserving the vessel, inspecting systems, replacing components, monitoring structural health, not because they enjoy maintenance, because their world depends on it. Another invisible threat emerges from a somewhat surprising source: vacuum itself. People often think of vacuum as simply nothing, the absence of air, the absence of matter. Yet maintaining a stable environment against vacuum requires constant vigilance. The pressure difference between a ship's interior and exterior is enormous. Every wall, every seal, every hatch, every window, every connection exists under continuous stress. Small leaks become important, large leaks become emergencies. Fortunately, engineers have considerable experience designing pressurized environments. Submarines, space stations, aircraft. Many technologies already operate under similar principles. The challenge once again comes from duration. Years become decades, decades become centuries. Materials age. Systems wear down. Unexpected failures occur. Future generations must continually preserve the integrity of their artificial world. It is easy to forget how much work Earth performs for us automatically. A planet requires no pressure hull, no atmosphere generators, no recycling machinery. Nature handles these tasks. Generation ships replace natural systems with engineered systems, and engineered systems demand attention. Yet perhaps the most fascinating invisible enemy is not a particle, not radiation, not vacuum. It is time itself, not in the philosophical sense, in the practical sense. Time wears things down. Every machine eventually ages. Every technology eventually becomes obsolete. Every design encounters challenges its creators never anticipated. Imagine using a computer built 400 years ago. The idea sounds absurd because computers did not exist 400 years ago. Now reverse the situation. Imagine future residents operating equipment designed centuries earlier. Some systems may be upgraded, others replaced, many redesigned entirely. The ship becomes a living technological ecosystem, constantly evolving, constantly adapting. because survival requires adaptation, this may actually become one of humanity's greatest strengths. We are exceptionally good at solving problems. History demonstrates this repeatedly. When faced with challenges, human beings invent, improve, modify, experiment. Generation-ship societies would likely continue that tradition. Their descendants may possess technologies the original founders never imagined. New materials, new manufacturing methods, new protective systems. The voyage itself could drive innovation. Ironically, the longer the journey lasts, the more opportunities future generations have to improve the ship. Of course, innovation introduces its own complications. Changes must be tested carefully. Critical systems cannot tolerate reckless experimentation. The society must balance stability with progress, preserve what works while improving what can be improved. Not an easy task. But then again, surviving among the stars was never going to be easy. What makes these invisible enemies so fascinating is that none of them resemble the threats commonly portrayed in adventure stories. No hostile alien fleets, no giant space monsters, no dramatic battles. The real dangers are quieter. Particles crossing unimaginable distances, tiny impacts accumulating over centuries, radiation slowly affecting living tissue, materials gradually aging, systems requiring continuous care. The universe rarely needs dramatic villains. Physics is perfectly capable of creating challenges on its own. And yet, despite all these hazards, survival remains possible. Difficult, certainly. Demanding, absolutely. Impossible? No. With sufficient planning, shielding, maintenance, and adaptability, a generation ship could potentially endure these threats for very long periods. The vessel becomes something remarkable. A tiny pocket of life-carrying humanity through an environment that was never meant for human beings. A fragile world protected against an indifferent universe. A curious thing happens when you walk through an old building. Perhaps it's a cathedral that has stood for centuries, a castle whose stones were placed by people long forgotten, or a bridge that has carried generations of travellers across the same river. You begin to notice something. The structure survived, but almost none of its original parts did. The roof was repaired, the windows were replaced, the foundations were reinforced, the walls were restored. Over time, piece after piece changed until very little of the original material remained, and yet we still consider it the same building. This raises an interesting question for our generation ship. If a spacecraft spends 500 years crossing the darkness between stars, what exactly survives? The original ship, or a succession of repairs and replacements that gradually transforms it into something entirely new? Because when most people imagine interstellar travel, they tend to focus on distance, fuel, engines, navigation, the spectacular parts of the mission. Yet history suggests a different challenge may prove even more important. Maintenance, the simple, unglamorous reality that everything eventually breaks. Every machine humanity has ever built wears down. Every technology ages. Every system requires care. The question isn't whether a generation ship will experience failures. It absolutely will. The real question is whether its descendants can continue repairing those failures century after century. At first glance, the answer seems obvious. Of course they can. After all, we repair things constantly. Cars break, computers fail, buildings deteriorate, people fix them. Problem solved. The difficulty appears when we consider timescale. A modern smartphone may last 5 years, a car perhaps 20. Commercial aircraft often remain in service for several decades. Even large infrastructure projects rarely operate unchanged for centuries. Generation ships demand something humanity has never achieved before, a technological system expected to remain functional longer than many civilizations. Imagine explaining the internet to someone living in the year 1500. The challenge isn't simply language. The entire technological foundation would be missing. No electricity, no computers, No telecommunications networks, no semiconductor manufacturing. The concepts themselves would seem magical. Now reverse the situation. Imagine someone from the year 2600 examining the systems aboard a generation ship launched in the year 2100. How primitive might those technologies appear? How many improvements would have emerged? How many original components would still exist? This is where generation ship design becomes surprisingly philosophical, because the goal may not be preserving technology, the goal may be preserving the ability to create technology. There is an important difference between the two. Consider a wrench. You can store a wrench for decades, perhaps even centuries under ideal conditions. Eventually, however, it wears out. The more valuable asset is not the wrench itself. It is the knowledge and capability required to manufacture another one. Generation ships therefore require something far more sophisticated than stockpiles. They require industrial continuity, the ability to keep making things again and again, generation after generation. This realization dramatically changes what must travel aboard the vessel. Suddenly, machine shops become essential. Manufacturing facilities become essential. Raw materials become essential. Technical education becomes essential. The ship is no longer carrying finished technology. It is carrying a technological civilization. That distinction cannot be overstated. A spacecraft expected to survive for centuries cannot rely on spare parts alone. No matter how large the inventory, eventually something unexpected will fail. History practically guarantees it. Engineers often joke that complex systems have a remarkable talent for breaking in ways nobody predicted. Generation ships would encounter thousands of such surprises. Perhaps a component degrades faster than expected. Maybe a manufacturing defect remains hidden for decades. Perhaps environmental conditions create unexpected stresses. Future generations must be prepared to solve problems their ancestors never imagined. Fortunately, human beings have considerable experience with this sort of thing. Look at any major city. The water systems have evolved repeatedly. Electrical grids have changed. Transportation networks have expanded. Entire technological layers have been added over time. Civilizations rarely remain static. They adapt continuously. A generation ship may operate similarly. Instead of preserving original designs forever, future residents might gradually redesign the vessel while travelling. New systems replace old systems. Improved technologies replace outdated technologies. The ship evolves. In some respects, this process resembles biological evolution. Living organisms survive not because they remain unchanged. They survive because they adapt. Generation ships may require the same principle. The vessel that arrives at another star could be dramatically different from the vessel that departed Earth. Not because the mission failed, because adaptation succeeded. Of course, adaptation creates another challenge: knowledge preservation. Technology only survives when people understand it. A machine can sit untouched for decades. Knowledge is more fragile. History provides countless examples. Ancient techniques disappeared. Languages became unreadable. Engineering methods were forgotten. Entire bodies of knowledge vanished when societies changed. Generation ships cannot afford that outcome. Imagine losing the ability to repair life support systems, or agricultural systems, or water purification systems. The consequences become immediate. As a result, education assumes an unusually important role. Future residents must learn far more than ordinary technical skills. They must inherit a complete understanding of the systems keeping their civilization alive. This creates one of the longest educational projects in human history. Every generation becomes responsible for teaching the next, not merely facts, competence, practical expertise, problem-solving ability. The distinction matters because technology rarely behaves exactly as textbooks predict. Real systems develop quirks, unexpected behaviors. Minor irregularities understood only through experience. Those lessons must also survive. Some researchers have proposed extensive knowledge archives, massive libraries preserving technical information. Others argue that knowledge remains safest when actively practiced rather than merely stored. A manual explaining how to repair a machine is valuable. A community of people regularly repairing machines is even better. In reality, generation ships would likely need both: documentation and experience, theory and practice. One particularly interesting possibility involves cultural attitudes toward maintenance. Modern societies often celebrate invention. Innovation receives attention. Breakthroughs receive headlines. Maintenance rarely does. Nobody writes dramatic movies about someone successfully inspecting air filters for 40 years. Yet maintenance may become one of the most respected professions aboard a generation ship. Think about it. A software engineer creating a new entertainment system contributes something useful. A technician ensuring the oxygen generators continue functioning contributes something essential. Over time, ship society may develop a deep appreciation for reliability, for competence, for people who quietly keep the world running, not because of ideology, because experience teaches their importance. After all, residents would witness the consequences directly. Every functioning system supports daily life. Every successful repair protects the future. Every maintenance schedule matters. In a closed environment, infrastructure becomes visible. On Earth, most people rarely think about electrical grids or water treatment facilities. Generation ship residents might think about them often. The entire civilization depends upon them. There is also the question of obsolescence. Technology changes rapidly. The computer in your pocket possesses more computing power than machines that once filled entire rooms. What happens when centuries pass? Do future residents continue using ancient systems? Or do they develop entirely new technologies? The likely answer is both. Some systems may remain remarkably stable. Basic engineering principles often endure for long periods. Others may evolve continuously. Computing systems, communication networks, manufacturing techniques, and medical technologies could transform repeatedly during the voyage. Future generations may possess capabilities the original founders never imagined. That possibility introduces an intriguing paradox. The descendants aboard a generation ship may eventually become more technologically advanced than the civilization that launched them. We often imagine the founding generation as the experts, yet centuries of accumulated experience can produce extraordinary expertise. Residents would spend their entire lives solving problems specific to long-duration space habitation. They may develop innovations uniquely suited to that environment. Their civilization evolves independently. By the time they arrive, they may have become something entirely new. History offers plenty of examples. Isolated communities frequently develop distinctive solutions to local challenges. Generation ships simply extend that process across centuries and light years. Of course, not all technological threats come from failure. Some come from success. Automation presents a fascinating example. Modern technology increasingly relies upon automated systems, artificial intelligence, self-monitoring equipment, autonomous maintenance. Future generation ships may depend heavily on similar technologies. At first, this seems beneficial. Machines handle repetitive tasks, efficiency improves, human workloads decrease, yet dependence creates risk. What happens if future generations gradually lose the ability to perform those tasks themselves? This concern already appears in modern society. Many people understand how to drive cars. Far fewer understand how engines actually work. Technology often hides complexity behind convenience. Generation ships must be careful not to lose critical expertise. The ideal balance may involve extensive automation paired with continuous education. Machines assist, humans remain capable. Redundancy becomes a guiding principle. Not merely redundant equipment, redundant knowledge, redundant skills, redundant capabilities. If one system fails, another takes over. If one expert retires, others possess similar expertise. If one solution stops working, alternatives exist. The longer the voyage, the more valuable redundancy becomes. Interestingly, some of the most important technologies aboard may be surprisingly simple. We tend to focus on advanced computers and sophisticated machinery, yet history demonstrates the value of basic tools. Mechanical systems often prove remarkably durable. Simple designs are easier to repair, easier to understand, easier to reproduce. Future ship designers may deliberately preserve low-tech alternatives alongside high-tech solutions, not because they dislike innovation, because resilience matters. Sometimes the best backup plan is simplicity. This mindset may shape the entire civilization. Residents learn to think in centuries rather than years. Durability becomes a cultural value. Repairability becomes a design priority. Long-term thinking becomes normal. After all, everyone aboard understands the same reality. Their world must survive. Not for a mission, not for a generation, for as long as necessary. And perhaps that is the most remarkable technological challenge of all. Building machines is difficult. Building machines that can be maintained for centuries is harder. Building a society capable of maintaining those machines may be the hardest task of all. Because in the end, technology does not survive by itself. People preserve it. People teach it. People improve it. People pass it forward. The true survival system aboard a generation ship is not any single machine. It is the civilization surrounding those machines, a civilization that learns, repairs, adapts, and continues. Yet even a technologically successful society faces another obstacle that no engineering manual can fully solve. The systems may function perfectly, the air may remain breathable, the food may continue growing, the machinery may continue operating. Consider the longest period you've ever spent waiting for something. Perhaps it was a delayed flight, a difficult exam result, a job interview, a medical appointment. Maybe it was simply the final hour of a workday that seemed determined to stretch itself into eternity. Human beings have a fascinating relationship with time. A pleasant evening can disappear in what feels like minutes. A boring afternoon can feel longer than a century. Now imagine living aboard a generation ship. Not for a few weeks, not for a few years, your entire life. Imagine knowing that the destination exists somewhere ahead of you, but also knowing with complete certainty that you will never see it. Your children probably won't see it. Perhaps your grandchildren won't either. The journey continues. The destination remains distant. The stars drift slowly past, and life goes on. This may be one of the most difficult psychological challenges ever faced by a human society. Because keeping people alive is one problem. Giving them a reason to keep moving forward is another. For most of history, human beings have lived with a fairly simple understanding of effort and reward. You work. Eventually you see results. A farmer plants seeds and later harvests crops. A builder constructs a house and eventually lives inside it. A student studies and earns a qualification. Actions and outcomes remain connected within a single lifetime. Generation ships disrupt that relationship. The original passengers make sacrifices whose rewards belong entirely to people they will never meet. This is not completely unfamiliar to humanity. Parents often work for futures they won't personally enjoy. Scientists conduct research whose benefits emerge decades later. Entire civilizations build projects intended for future generations. Yet generation ships elevate that principle to an extraordinary level. Imagine helping construct a vessel destined to arrive 400 years after your death. Every day of your life contributes to a goal you will never personally experience. Some people might find that inspiring. Others might find it difficult. Most would probably feel both emotions simultaneously. Psychologists have spent years thinking about this problem. One question appears again and again. How do you maintain meaning during an endless journey? meaning turns out to be remarkably important. Human beings tolerate extraordinary hardship when they understand why it exists. History provides countless examples. People endure dangerous expeditions, extreme environments, long periods of isolation, remarkable sacrifices, often because they believe their suffering serves a larger purpose. Purpose acts like psychological fuel. Remove it, and motivation becomes harder to sustain. Generation ships therefore face a unique challenge. The original mission must remain meaningful across centuries, not merely understood, felt. A child born 300 years into the voyage needs some reason to care about a destination they will never reach. And unlike technical problems, there is no simple engineering solution. You cannot install an extra meaning generator. You cannot manufacture motivation in a factory. Purpose emerges from culture, community, identity, shared beliefs. The society itself must create it. Interestingly, human history suggests this may be possible. People already participate in projects extending beyond individual lifetimes. Religions endure for centuries. Universities survive for centuries. Nations survive for centuries. Many institutions continue because each generation teaches the next why they matter. Generation ships may function similarly. The mission becomes part of cultural identity. Children grow up hearing stories about the journey. The destination becomes woven into education, traditions, and daily life, not as a distant objective, as part of who they are. Yet even strong cultural purpose may not eliminate another challenge: monotony. Deep space is not famous for excitement. The average Tuesday aboard a generation ship is unlikely to involve dramatic encounters with alien civilizations. Most days will probably look remarkably ordinary. People wake up, go to work, attend school, prepare meals, spend time with friends, go to sleep, repeat. The routines themselves are not the problem. Humans generally like routines. The difficulty comes from confinement, the same corridors, the same neighborhoods, the same artificial sky, the same environment year after year. Imagine never leaving your hometown. Then imagine your hometown is enclosed within a spacecraft. For an entire lifetime, some individuals might adapt easily, others may struggle. Psychological diversity is one of humanity's defining characteristics. People respond differently to identical environments. What feels comfortable to one person may feel restrictive to another. Generation ships must accommodate that reality. This is one reason many proposed designs include surprisingly large communal spaces. Not because they're efficient, because they're psychologically valuable. People need room, not necessarily physical room, perceived room. The sensation that the environment remains open and varied. Some architects envision parks, artificial forests, walking paths, open plazas, large recreational areas. The goal is not simply survival. The goal is creating an environment that feels alive. After all, nobody wants to spend 80 years feeling trapped inside a machine. The challenge becomes even more interesting when we consider children. A person born aboard the vessel experiences confinement differently than someone who remembers Earth. The original passengers compare ship life to planetary life. Future generations cannot. The ship becomes normal. In many ways, they may adapt better. Humans are remarkably good at accepting whatever environment they grow up within. Children rarely question normality. Normal is simply whatever surrounds them. A child raised aboard a generation ship may find the vessel perfectly comfortable, perhaps even beautiful. The corridors become familiar streets. The agricultural sectors become countryside. The communal spaces become gathering places. Home is home, no matter where it happens to be. This adaptation could prove enormously beneficial. Yet it may also create unexpected tensions. Imagine a future generation no longer interested in reaching the destination. The founders view arrival as the ultimate goal. Their descendants may disagree. Some residents might argue that the ship itself has become their civilization. Why leave? Why abandon a world that has supported countless generations? This possibility has fascinated sociologists for decades. Could a generation ship eventually develop competing visions of its future? Some residents favouring arrival, others favouring continued travel, still others preferring entirely different goals. History suggests such disagreements are practically inevitable. Human beings rarely agree about everything, and that's probably healthy. Diverse perspectives often produce better solutions. The challenge lies in managing disagreement constructively, particularly inside a closed environment. On Earth, people dissatisfied with their circumstances often move elsewhere. Different city, different country, different community. Generation ships offer fewer options. The population remains together. Conflicts cannot simply be escaped. They must be resolved. This reality may shape social structures in interesting ways. Future ship societies might place extraordinary emphasis on conflict resolution, communication skills, community decision-making, long-term cooperation, not because people become unusually virtuous, because practical necessity demands it. The alternative carries significant risks. There is another psychological factor that often receives less attention. Boredom. Not ordinary boredom, generational boredom. Human beings evolved in dynamic environments. Weather changes, landscapes vary, unexpected events occur. Generation ships must deliberately create variety. Entertainment becomes essential infrastructure. That may sound odd at first. Entertainment often feels optional, a luxury rather than a necessity. Psychologists increasingly recognize a different reality. Play matters, art matters. Music matters, stories matter. Leisure contributes significantly to mental health. Future residents will need opportunities for creativity and self-expression. The ship may contain theatres, sports facilities, virtual reality systems, libraries, museums, countless forms of recreation. Not because civilization has excess resources, because psychological well-being requires investment. Imagine living in a society where every moment focused exclusively on survival, work, maintenance, resource management, nothing else. Such a civilization might function briefly. Eventually people would begin struggling. Human beings need more than existence. We need experiences, connections, moments of joy. Generation ship designers increasingly recognize this reality. The most successful vessel may not be the one with the most efficient systems. It may be the one where people genuinely enjoy living. Perhaps the most intriguing question concerns identity. Who exactly are the descendants aboard a generation ship? Earthborn humans? Interstellar humans? Something entirely new. Identity influences psychology profoundly. People generally want to belong to something larger than themselves. Families, communities, cultures, nations. Generation ships may eventually create entirely new forms of belonging. Residents share a common environment unlike anything in human history, a common journey, a common destiny. Over centuries, these shared experiences could produce a powerful collective identity, not based on geography, based on voyage. This identity may help sustain psychological resilience. Humans are social creatures. We derive strength from connection. The stronger the community, the easier it becomes to face challenges. That principle has appeared repeatedly throughout history. It would likely remain true among the stars. Of course, even the healthiest society cannot eliminate every difficulty. People will still experience grief, disappointment, anxiety, loss. Mental illness does not disappear simply because civilization leaves Earth. In fact, some conditions may become more common under prolonged isolation. Future medical systems will likely devote significant attention to psychological health, counseling, therapy, social support, community programs. Mental well-being becomes just as important as physical well-being, perhaps more important. Because an unhappy civilization may struggle even when every technical system functions perfectly, and that observation reveals something fundamental about generation ships. The greatest challenge may never be engineering, it may never be radiation, it may never be food production. The greatest challenge may be maintaining a healthy human society across centuries, a community capable of finding purpose despite distance, hope despite uncertainty, meaning despite never reaching the destination. Fortunately, human history provides reasons for optimism. Our species has repeatedly demonstrated an extraordinary capacity for adaptation. We create cultures wherever we go. We build communities under difficult circumstances. We tell stories that connect generations. We find reasons to continue. The descendants born among the stars may ultimately thrive not because the journey is easy, because they no longer see it as a journey. For them it is simply life, their world, their home, their civilization. And as that civilization continues evolving through the centuries, something fascinating begins to happen. Earth gradually recedes into history. The planet that launched the mission grows more distant with every passing generation. Memories become stories, stories become traditions, traditions become legends, until eventually a new question emerges. What happens when the place humanity came from starts feeling less real than the ship itself? Walk into almost any city on Earth, and you'll find reminders of people who lived long before us. Ancient buildings, old monuments, historical documents, stories passed from one generation to another. Yet even with all those reminders surrounding us, most people rarely feel emotionally connected to events that happened hundreds of years ago. We know they occurred, we study them in school, we read about them in books, but they often feel distant, abstract, separated from everyday life by an invisible wall of time. Now imagine a child born aboard a generation ship 600 years after departure. Imagine asking that child about Earth, not the Earth of astronomy textbooks, not the Earth visible through historical records, the Earth that launched the mission, the Earth where humanity once lived beneath open skies. To that child, Earth may feel less like a homeland and more like ancient history, something halfway between a fact and a legend. And that raises one of the most fascinating questions in the entire generation ship concept. What happens when the world that created the mission slowly becomes a myth? At first, the answer seems obvious. Future generations will simply study history. Problem solved. After all, modern people learn about ancient civilizations. We know about Egypt, Rome, Mesopotamia, China's earliest dynasties, countless cultures that existed long before our births. Surely future ship residents can learn about Earth the same way. In one sense, that's true. Information can survive, records can survive, images can survive. The challenge is an emotional distance. Knowledge and connection are not the same thing. Most people know the Roman Empire existed. Very few feel personally connected to it. The difference matters. Generation ships rely heavily on cultural continuity. The original mission must remain meaningful across centuries. That task becomes increasingly difficult as the founders fade into history. Imagine the first generation aboard the ship. They remember Earth directly. They remember oceans, clouds, rain, forests, cities, mountains. The memories are vivid, personal, real. When they tell stories about Earth, they speak from experience. Their children inherit those stories. The children still know people who actually lived there. Grandparents describe sunsets. Parents describe beaches. Teachers describe the launch. Earth remains emotionally close. Now move forward another 100 years. The direct witnesses are gone. Stories survive. Photographs survive. Videos survive. But nobody remembers personally. Earth becomes something learned rather than experienced. Advance another 2 centuries. The process continues. Historical accounts remain. Educational materials remain. Yet emotional distance grows steadily. At some point, a curious transformation begins. Earth becomes an idea, a symbol, a place everyone knows about but nobody has seen. And humans have a long history of treating distant places in interesting ways. Consider ancient homelands remembered through generations of migration. Many communities preserve stories about ancestral lands for centuries. The details often changed. Some memories remained accurate, others became idealized. A few evolved into something resembling mythology, not because anyone intended deception, because memory itself changes over time. Generation ships would likely experience a similar process. Earth might remain historically accurate in official records. At the same time, cultural stories could gradually transform it into something larger than life. Future residents might imagine Earth as a nearly magical place, a world of endless oceans, vast forests, open skies stretching beyond sight. To people who have spent their entire lives inside a spacecraft, those descriptions could sound almost unbelievable. Imagine trying to explain weather to someone who has never experienced it. Not simply rain, weather itself, clouds forming naturally, storms arriving unexpectedly, wind moving across landscapes, snow falling from the sky. To modern listeners, these things seem ordinary. To someone born aboard a generation ship, they may sound extraordinary. In fact, future children might struggle to grasp certain concepts entirely. How do you explain a horizon to someone raised inside an enclosed habitat? How do you explain standing on a beach and seeing water extend farther than the eye can see? How do you explain mountains that were not built by engineers? Some experiences resist description. They must be lived, and generation ship residents would never live them. This creates an interesting possibility. Future cultures may begin creating their own interpretations of Earth. Artistic interpretations, cultural interpretations, emotional interpretations. Not because historical records disappeared, because human beings naturally build stories around important places. Earth would certainly qualify as important. After all, it represents the birthplace of the entire civilization, the origin of everything. There is another factor complicating matters: language. Languages never remain frozen. The English spoken today differs dramatically from the English spoken centuries ago. Future ship societies will almost certainly experience similar changes. Words evolve, meanings shift, expressions appear and disappear. Over hundreds of years, even carefully preserved historical documents may begin requiring translation. The original accounts remain available. Understanding them becomes increasingly specialized. Something similar already happens with historical texts today. Most modern English speakers cannot comfortably read Old English. The language changed. Generation ships would experience the same process. Future historians may study ancient Earth records much the way modern historians study medieval manuscripts. The information survives. The connection becomes academic. This shift could profoundly affect identity. Think about how many people today identify strongly with nations, countries, regions, places. Geography shapes identity. Generation ships remove geography and replace it with something unusual: the ship itself. As centuries pass, residents may increasingly identify not as descendants of Earth, but as citizens of the vessel. Their homeland is not a planet. Their homeland is a moving world, a civilization travelling through darkness. This may sound strange to us because we grew up on planets. Future generations would not share that perspective. For them, belonging to the ship feels completely normal. Earth becomes ancestry. The ship becomes home. History offers useful parallels. Many immigrant communities maintain strong connections to ancestral homelands. Over time, however, those connections often evolve. Descendants appreciate their heritage while simultaneously developing new identities tied to where they actually live. Generation ships may follow a similar pattern. Residents remember Earth, honour Earth, study Earth, yet increasingly define themselves through their own society, not because they reject humanity's origins, because daily life shapes identity more strongly than distant history. The process could become particularly noticeable during cultural celebrations. Imagine a holiday commemorating departure from Earth. The original founders treat it with deep emotion. They remember the event. Their grandchildren treat it as family history. Their descendants centuries later may celebrate it much like modern societies celebrate historical anniversaries. Still important, still meaningful, but emotionally different. The same event acquires new meanings over time. Traditions evolve, symbols evolve, interpretations evolve. That is what cultures do. One fascinating possibility involves religion. Throughout history, major journeys have often influenced spiritual beliefs. Migration, exploration, exile, pilgrimage. Human beings frequently seek larger meaning within long and uncertain journeys. Generation ships may prove no exception. Future belief systems could emerge around themes of voyage, stewardship, ancestry, and destiny. Some communities might develop spiritual traditions emphasizing arrival. Others may emphasize the journey itself. Still others could focus on preserving humanity's legacy among the stars. Predicting specific outcomes is impossible. The broader pattern seems likely. People will search for meaning. People always do. Earth's role within those belief systems could become increasingly symbolic. Not merely a planet, a place of origin, a beginning, a source. Again, not because historical facts disappear, because symbols often carry emotional weight beyond factual descriptions. Interestingly, the opposite transformation may also occur. Some future residents might become fascinated by historical accuracy. The greater the distance from Earth, the stronger the desire to preserve authentic knowledge. Historians aboard the vessel could devote enormous effort to maintaining records. Museums may preserve artifacts from departure. Libraries may protect cultural heritage. Educational institutions may teach Earth's history in extraordinary detail. Future generations might know more about Earth's past than many people living today. Distance sometimes increases appreciation. The result could be a curious mixture. Earth simultaneously functioning as history, heritage, symbol, and myth. Not myth in the sense of falsehood. Myth in the sense of cultural importance. A place carrying meanings larger than itself. There is another possibility worth considering. Communication. During the early stages of the voyage, messages between Earth and the ship remain practical. Slow, certainly, but practical. As distances increase, communication becomes increasingly difficult. Years pass between messages. Then decades. Eventually, depending on the mission profile, communication may cease entirely. Perhaps Earth continues transmitting. Perhaps it doesn't. Perhaps humanity changes dramatically. Perhaps it spreads to other worlds. Perhaps entirely unexpected events occur. Future generations aboard the ship may know less and less about what happened after departure. This uncertainty introduces a remarkable psychological situation. Earth becomes both known and unknown simultaneously. Residents know where they came from. They may have little idea what Earth eventually became. Imagine discovering that the last reliable information about your ancestral home is 300 years old. Everything after that remains uncertain. The imagination naturally begins filling gaps. Stories emerge, speculation emerges, curiosity remains. Human beings rarely tolerate mysteries quietly. The less information available, the more intriguing the mystery becomes. Earth may gradually acquire an almost legendary quality, not because nobody knows it existed, because nobody knows exactly what happened afterward. Did civilization flourish? Did humanity spread across the galaxy? Did entirely new cultures emerge? Future residents might debate these questions endlessly, and in a strange way, that uncertainty could strengthen Earth's role within ship culture. Mysteries often remain culturally powerful. The unknown invites imagination. The known rarely does. Perhaps the most remarkable aspect of all this is that none of it represents failure. Quite the opposite. If Earth eventually feels distant, it means the generation ship succeeded in creating a real civilization, a genuine society, a culture capable of standing on its own. Children born aboard the vessel would not spend every day longing for a planet they never knew. They would build lives, friendships, families, dreams. Their future would exist where they actually lived, inside the ship. Among their own communities, that is what healthy societies do. They create belonging. And yet, while culture, identity, and history continue evolving, another process unfolds quietly beneath the surface. One that cares very little about traditions or stories. Generation after generation is born aboard the vessel. Generation after generation grows up within the same artificial environment. Over centuries, those conditions begin exerting subtle influences on the human body itself. Because while culture can change remarkably quickly, biology is always changing too. And once enough time passes among the stars, an intriguing question begins to emerge. Will the descendants arriving at another world still be exactly the same as the humans who left Earth behind? Step outside on Earth, and your body immediately begins interacting with the planet in ways you probably never notice. Gravity pulls gently downward. Sunlight reaches your skin. The atmosphere surrounds you. Countless microorganisms share the environment. Day turns into night. Seasons come and go. Temperature changes, humidity changes, pressure changes. Life on Earth evolved within this endlessly complex system for billions of years. Every human who has ever lived is in a sense a product of that environment. Now imagine removing humanity from it. Not for a few months, not for a few years, but for centuries. Imagine generation after generation growing up inside an artificial world travelling between the stars. The air remains controlled. The temperature remains controlled. The gravity may be artificial. The environment becomes predictable in ways Earth never is. Eventually, a fascinating question begins to emerge. What happens to the human body when it spends hundreds of years living somewhere it was never designed to live? At first glance, the answer seems simple. Nothing happens. After all, the people aboard the ship remain human. They eat food, drink water, raise families, live ordinary lives. And to a large extent that is true. A generation ship is not a different planet. It is still inhabited by human beings. The descendants born aboard remain members of the same species as their ancestors. Yet biology rarely stays completely still. Change is one of its defining characteristics. Every generation differs slightly from the one before it. Mutations occur, genes are shuffled, traits become more common, others become less common. Most of these changes are so subtle that nobody notices them. Evolution rarely announces itself. It prefers patience. A generation ship may provide evolution with plenty of patience. To understand why, it helps to remember that evolution does not require dramatic transformations. People often imagine evolution as a process that turns one creature into something completely different. In reality, it usually operates through tiny changes accumulating over long periods. A slightly advantageous trait becomes more common. A slightly disadvantageous trait becomes less common. Generation after generation, the population gradually shifts. The process is slow, but centuries provide plenty of time for slow processes. Now, before anyone imagines future ship residents developing tentacles or glowing in the dark, it's important to keep expectations realistic. The voyage may last hundreds of years, perhaps even 1,000. In evolutionary terms, that is significant but not enormous. Humans would remain recognizably human. The interesting question concerns subtler changes, adaptations to life aboard the vessel. Consider gravity. Many generation ship designs rely on artificial gravity created through rotation. The concept is clever. Spin part of the ship and centrifugal force presses people against the outer surface. To residents, it feels remarkably similar to gravity. Yet similar is not necessarily identical. Small differences could exist. Perhaps gravity aboard the vessel is slightly weaker than Earth's. Perhaps it varies slightly between locations. Perhaps future engineers intentionally choose different levels. If such conditions persist for centuries, natural selection may eventually favour traits better suited to that environment. Again, not dramatic transformations. Tiny advantages, tiny adjustments. Biology specialises in tiny adjustments. The same principle applies to radiation. Deep space exposes populations to conditions unlike those experienced on Earth. Even with extensive shielding, radiation levels may differ slightly from those found on the planet where humanity evolved. Cells continually repair radiation damage. Some people naturally possess more effective repair mechanisms than others. Over many generations, subtle shifts in population genetics could occur. Individuals with traits enhancing survival may gradually become more common. Nobody notices it happening. Evolution rarely seeks attention. Then there is the issue of population size. Earth contains billions of people. Generation ships contain thousands, perhaps tens of thousands. The difference matters. Large populations contain enormous genetic diversity. Smaller populations contain less. This creates a phenomenon known as genetic drift. Unlike natural selection, which favours advantageous traits, genetic drift often involves random changes. Certain genes become more common simply by chance. Others become less common. The effect becomes more pronounced in smaller populations. Imagine a jar filled with thousands of coloured marbles. Remove a handful. The proportions remain roughly the same. Now imagine a much smaller jar. Remove the same handful. The proportions change dramatically. Population genetics sometimes work similarly. Generation ships must carefully manage this challenge. Future residents will likely maintain detailed genetic records. Medical systems may monitor diversity. Population planning may help prevent harmful bottlenecks. All of this sounds highly technical. In practice, it may become completely routine. Future ship societies might treat genetic management much the way modern societies treat public health. Not unusual, not controversial. Simply another part of maintaining civilization. Of course, genetics tells only part of the story. Human bodies respond to environments throughout life, not merely across generations. One of the most fascinating examples involves bone density. Astronauts living in microgravity lose bone mass surprisingly quickly. Without gravity constantly pulling downward, the body concludes that strong bones are less necessary. Bone tissue gradually decreases, muscles weaken. The body adapts to its circumstances. Generation ships attempt to prevent this through artificial gravity. Yet the broader lesson remains important. Human physiology responds continuously to environmental conditions. Future residents may experience subtle differences from Earth populations. Not because evolution transformed them, because development itself responds to surroundings. Think about height. Nutrition affects height. Health affects height. Environmental conditions affect height. The average person aboard a generation ship may not look exactly like the average person living on Earth centuries earlier. The differences could be small. They could also accumulate over time. Another fascinating possibility involves the immune system. Earth is full of biological diversity. Bacteria, viruses, fungi. Countless microorganisms surround us constantly. Generation ships would likely contain their own microbial ecosystems. These ecosystems may evolve independently over centuries. Microorganisms reproduce quickly, far more quickly than humans. A bacterium can experience countless generations while a single human lifetime passes. The microbial world aboard the ship would become an evolutionary laboratory. New strains emerge, old strains disappear. Complex ecological relationships develop. Human immune systems must adapt accordingly. Future doctors may spend considerable effort monitoring these invisible ecosystems, not because something has gone wrong, because maintaining balance matters. After all, civilization aboard the vessel depends upon health. Interestingly, the relationship works both ways. Humans influence microorganisms Microorganisms influence humans. The ship becomes a giant interconnected biological system. Every resident participates whether they realize it or not. This may sound unusual. In truth, the same thing happens on Earth. We simply tend not to notice it. Generation ships make hidden relationships more visible. There's another question that often captures people's imagination. Could humans eventually become a new species? The answer is probably not during a typical generation ship voyage. Speciation usually requires much longer timescales, thousands upon thousands of years, often longer. A voyage lasting several centuries might produce measurable differences. A completely new species is another matter entirely. Future residents remain human. Their descendants remain human. The more interesting possibility involves cultural and biological adaptation occurring together. Imagine children growing up in an environment specifically designed for space habitation. Their education reflects that reality. Their daily routines reflect that reality. Their bodies develop within that reality. Over time, they become specialists in a world their ancestors created, not genetically separate from humanity, uniquely experienced, uniquely adapted, uniquely shaped by life among the stars. History already provides examples of similar processes. Populations living in high mountains often develop adaptations for lower oxygen levels. Communities living in different climates develop different physiological tendencies. Human beings are remarkably flexible. Generation ships simply introduce a new environment, one unlike any that came before. Perhaps the most profound change, however, may have little to do with biology itself. It may involve perception, how future residents think about their bodies. On Earth, we often take our environment for granted. The atmosphere exists, gravity exists, sunlight exists. Generation ship residents grow up knowing these things require active maintenance. Their relationship with biology may become unusually conscious. People understand where their food comes from, how their air is produced, how water is recycled, how environmental conditions affect health. The connection between civilization and biology becomes impossible to ignore. This awareness could influence everything from education to healthcare. Future generations may possess a remarkably sophisticated understanding of human physiology, not because they are inherently smarter, because their environment constantly reminds them how important biology is. Every successful birth, every healthy child, every functioning ecosystem contributes directly to the survival of civilization. Over centuries, that reality shapes priorities, it shapes institutions, it shapes culture. And perhaps that is the most important lesson hidden within all this discussion of evolution and genetics. The future residents of a generation ship are not merely passengers. They are participants in an ongoing experiment, not a scientific experiment imposed upon them, a natural experiment created by circumstance. Humanity carrying itself into a completely new environment and discovering generation by generation how life responds. Some changes may be biological, some psychological, some cultural. Most likely all three influence one another. Nobody likes thinking about disasters. It's one of those subjects we tend to quietly push aside. The roof probably won't collapse. The power probably won't fail. The airplane will probably land safely. The bridge will probably hold. And most of the time, we're right. Modern life works remarkably well because countless systems function exactly as intended every single day. Generation ships, however, cannot afford the luxury of assuming everything will go according to plan, not because their designers are pessimists, because time changes the mathematics. A problem that has a 1 in a million chance of occurring this year becomes much more likely if your civilization must survive for 500 years. Extend the timeline long enough, an unlikely event stops feeling unlikely. Eventually, something goes wrong. The real question is what happens next. This idea sits at the heart of nearly every serious generation ship study. Engineers don't spend most of their time asking how systems work when everything goes perfectly. They ask what happens when things don't. What happens if a machine fails? What happens if crops die? What happens if people disagree? What happens if a critical system suddenly stops functioning? Because in deep space there is no emergency phone number, no rescue helicopter, no neighbouring city sending aid. Whatever problem appears belongs entirely to the people aboard the ship. Imagine waking up one ordinary morning. The lights come on, breakfast is served, children head to school, people begin work, everything feels normal. Then a maintenance team discovers a problem. Perhaps a water recycling system has developed contamination. Perhaps an agricultural disease is spreading through a food production area. Perhaps a critical manufacturing machine suffers unexpected damage. At first, the issue affects only a small section of the ship. Then people begin asking an uncomfortable question. Can it be fixed? On Earth, most crises remain local. If one city experiences difficulties, assistance arrives from elsewhere. Resources flow across continents. Specialists travel where needed. Entire nations can mobilize support. Generation ships lack that option. Every crisis becomes an internal affair. This reality transforms redundancy into one of the most important concepts aboard the vessel. Redundancy sounds boring. Engineers love it. Everyone else tends to ignore it. Until something fails, then redundancy suddenly becomes very exciting. Imagine a ship with only one oxygen generation system. The system fails. Civilization ends. The solution is obvious. Build 2 systems, or 3, or 10. Generation ship designers assume critical systems will eventually break. The goal is ensuring alternatives exist when they do. Multiple water systems, multiple power systems, multiple agricultural facilities, multiple communication networks. The ship becomes a collection of backups supporting other backups. It may appear excessive. Centuries of survival demand excess. History consistently rewards civilizations that prepare for failure. Now consider a different scenario, not a mechanical problem, a biological one. Throughout human history, disease has repeatedly altered societies. Pandemics have reshaped nations, changed economies, influenced politics, affected entire civilizations. Generation ships must confront the same possibility. In fact, their isolation creates unusual complications. At first glance, isolation sounds beneficial. No new diseases arrive from outside. No travelers introduce unfamiliar infections. No global transportation network spreads illness. Those advantages are real. Yet isolation also creates vulnerabilities. A disease emerging within the ship remains inside the ship. The population cannot easily disperse. The community shares air systems, public spaces, workplaces, and homes. Future medical systems would likely monitor health continuously, not because residents are constantly sick, because prevention becomes extraordinarily valuable. Detecting problems early could save countless lives. Advanced medical surveillance may become routine. Artificial intelligence may help identify unusual patterns. Genetic sequencing may track emerging threats. Medicine aboard a generation ship could become remarkably sophisticated. It would almost have to. Then there are agricultural crises. Civilizations depend upon food. That statement sounds obvious until food becomes uncertain. Imagine a fungal infection affecting a major crop, or a nutrient imbalance spreading through agricultural systems, or a pollination problem reducing yields. Earth possesses vast agricultural diversity. A failed harvest in one region can often be offset elsewhere. Generation ships operate within a much smaller ecosystem. The margin for error shrinks. Future societies may therefore maintain extraordinary agricultural redundancy. Multiple crop species, multiple growing methods, extensive seed banks. Carefully preserved genetic diversity. The goal is resilience. If one food source struggles, others remain available. Nature itself offers useful lessons. Healthy ecosystems rarely depend entirely upon a single species. Generation ships may follow similar principles. Diversification becomes protection. Yet some crises have nothing to do with biology or engineering. Some involve people. Human beings are wonderfully creative, remarkably adaptable, occasionally difficult. History demonstrates all three qualities repeatedly. Generation ships will not magically eliminate disagreement. People will continue arguing about politics, leadership, resources, priorities, the future. Human nature travels with the ship. Imagine a population several centuries into the voyage. New generations have grown up aboard the vessel. Different ideas emerge regarding how society should operate. Some residents favour preserving old traditions. Others advocate major changes. Disagreements appear. This is perfectly normal. In many ways, disagreement reflects a healthy society. The challenge lies in preventing disagreements from becoming destructive. Earth possesses numerous mechanisms for handling conflict. People relocate, communities separate, nations maintain borders, generation ships offer fewer escape routes. Everyone shares the same world, literally. The walls surrounding one group surround everyone else as well. This reality may encourage unusually sophisticated systems of governance. Future societies might devote significant effort to mediation, negotiation, and collective decision-making. Not because conflict disappears, because conflict becomes too important to ignore. A prolonged internal crisis could threaten the entire community. The stakes remain high. There is also the possibility of population decline. Modern discussions often focus on overpopulation. Generation ships must consider the opposite risk as well. What happens if birth rates fall dramatically? What happens if a disease reduces population size? What happens if a major accident claims lives? Small populations face unique challenges. Fewer workers, fewer specialists, reduced genetic diversity. A civilization surviving centuries must maintain demographic stability. This may require careful planning, continuous monitoring, long-term thinking. Again, not because future societies become obsessed with control, because mathematics remain stubbornly indifferent to preferences. Population dynamics matter. The ship cannot ignore them. Another intriguing scenario involves knowledge loss. Imagine a critical skill gradually disappearing, not suddenly, slowly. A few experts retire. Training standards decline slightly. Documentation becomes outdated. Generation after generation, knowledge erodes. Eventually, people realize nobody fully understands an important system anymore. History provides numerous examples of lost knowledge. Ancient construction techniques vanished. Manufacturing methods disappeared. Languages became unreadable. Generation ships must actively prevent similar outcomes. The challenge becomes especially difficult because loss often happens gradually. No alarm sounds, no warning light flashes. The problem reveals itself only when expertise becomes necessary. Future educational systems would likely place enormous emphasis on preserving critical skills, not merely information, competence, the ability to actually do things. This distinction matters. Reading about engineering and practicing engineering are not the same experience. Civilization requires both. Perhaps the most frightening scenario involves cascading failures. One system experiences trouble. That trouble affects another system, which affects another, which affects another. The problems multiply. Engineers sometimes describe this as a domino effect. One falling piece triggers many others. Modern societies occasionally experience similar events. Power outages affect transportation. Transportation affects supply chains. Supply chains affect businesses. Everything connects. Generation ships may prove even more interconnected. Air systems affect agriculture. Agriculture affects food production. Food production affects population health. Population health affects workforce capability. The relationships become complex. This is precisely why redundancy and resilience matter so much. The ship must absorb shocks without collapsing. Like a healthy ecosystem, like a healthy civilization, like a healthy body, adaptation becomes survival. Yet amid all these discussions of crisis, it is worth remembering something important. Human beings are exceptionally good at solving problems. In fact, most of civilization's greatest achievements emerged because problems existed. Challenges inspire innovation. Constraints inspire creativity. Difficult circumstances often reveal unexpected strengths. The descendants aboard a generation ship may become masters of resilience, generation after generation learning how to adapt, how to recover, how to continue. After all, their entire society depends upon those skills. Perhaps the most realistic vision of a successful generation ship is not one that avoids every crisis. Such a ship probably does not exist. The realistic vision is a civilization capable of surviving crises, recovering from mistakes, learning from failures, continuing despite setbacks. Because over hundreds of years, perfection is impossible, resilience is achievable, and if the community can master resilience, something remarkable becomes possible. The ship survives, the population survives, the culture survives. Generation after generation continues the journey. Meanwhile, far away, Earth continues its own story. Centuries pass, history unfolds, civilizations rise and fall, technologies advance, entire eras come and go. And eventually another strange possibility emerges. The people aboard the vessel may discover that they have endured longer than the society that launched them. The ship continues moving steadily through the darkness. But what if the civilization left behind changed beyond recognition long ago, or disappeared entirely? What if, somewhere along the voyage, the generation ship became one of humanity's oldest surviving civilizations? Long before anyone listening tonight was born, there were cities that seemed permanent. Their people looked at towering walls, bustling streets, magnificent temples, and crowded marketplaces and assumed they would always be there. The future stretched ahead. Civilization appeared secure. Life continued much as it always had. Then something changed. Sometimes it was war, sometimes disease, sometimes economic collapse, sometimes environmental pressure. Occasionally, several problems arrived together. And eventually, cities that once felt eternal became archaeological sites. Their streets fell silent, their languages disappeared, their rulers became names in history books. Human beings have a curious habit of assuming the present will last forever. History repeatedly suggests otherwise. Now imagine a generation ship drifting steadily between the stars. A century passes, then another, then another. The descendants of the original passengers continue living their lives. Children are born. Families grow, society evolves, the ship continues its journey. Meanwhile, back on Earth, history keeps moving, and sooner or later, a fascinating question begins to emerge. What if the generation ship survives longer than the civilization that launched it? At first glance, the idea sounds dramatic, perhaps even unlikely. After all, Earth is an entire planet. A generation ship is a single vessel. Surely the planet possesses the advantage. Yet when we examine history, the comparison becomes more complicated. Civilizations are surprisingly fragile. Human beings are resilient. Civilizations less so. The distinction matters. Ancient Egypt lasted thousands of years, but it changed repeatedly throughout that time. Empires rose and fell. Dynasties appeared and vanished. Political systems transformed. Languages evolved. What historians call ancient Egypt was actually a constantly changing collection of societies spread across immense stretches of time. The Roman Empire eventually fragmented. The Maya experienced periods of decline. Countless kingdoms, nations, and cultures flourished before fading into history. The people did not vanish. Humanity continued. Civilizations changed. generation ships introduce an unusual possibility, a society deliberately designed to endure centuries, perhaps even millennia, not because it is stronger than every civilization in history, because survival becomes its primary purpose. Think about modern nations. Most are trying to accomplish many things simultaneously: economic growth, scientific advancement, political stability, cultural development, international influence. Generation ships operate under different conditions. Their most important objective is remarkably simple: keep civilization alive. Everything else supports that goal. Food production supports survival. Education supports survival. Technology supports survival. Population management supports survival. The entire system revolves around continuity. In some respects, this focus may provide advantages. Throughout history, many civilizations collapsed because external pressures overwhelmed internal stability. Invading armies, resource shortages, geographic competition, trade disruptions. Generation ships eliminate some of these risks entirely. There are no neighboring empires, no rival nations, no shifting borders, no international conflicts. The civilization exists alone. Of course, isolation creates its own challenges. We've already explored many of them. Yet the absence of external competition changes the equation dramatically. A generation ship may spend centuries concentrating on long-term sustainability, while Earth continues experiencing the unpredictable turbulence of history. This becomes particularly interesting when we consider communication. Imagine a vessel launched in the year 2200. The journey requires 600 years. During the early stages, communication with Earth remains possible. Messages travel slowly but reliably. News arrives, updates arrive, the connection survives. Then decades pass. The distance grows. Communication delays increase. Eventually, receiving a simple reply might require many years, then many decades. At some point, practical conversation becomes impossible. Earth continues existing. The ship continues traveling. The connection weakens. Now imagine something unexpected happens. Perhaps civilization on Earth changes dramatically. Perhaps humanity spreads across multiple star systems. Perhaps political systems transform beyond recognition. Perhaps entirely new cultures emerge. The descendants aboard the generation ship may never know. From their perspective, Earth gradually becomes a historical mystery. The last confirmed information grows older and older. Imagine receiving a message from Earth, then another, then another. Eventually the final message arrives, not because Earth disappeared, simply because communication became impractical. Years pass, decades pass, generations pass, the ship continues moving, no new information arrives, future residents know Earth exists. They have no idea what Earth has become. This creates one of the strangest situations in human history. A civilization separated not only by distance, but by uncertainty. History begins unfolding independently on both sides. The descendants aboard the vessel develop their own culture. Earth develops its own future. Neither fully understands the other. Eventually, the generation ship may become something more than an expedition. It may become an independent branch of human civilization. History already provides smaller examples. When groups become isolated, they develop distinct identities, different customs, different traditions, different perspectives. Generation ships simply extend that process across centuries and light years. The result could be extraordinary. Imagine two human civilizations sharing common origins but separated for hundreds of years. One remained on Earth. The other crossed interstellar space. Both changed, both evolved, both remained human. Yet each became something unique. The more time passes, the greater those differences may become. Now consider another possibility, a less comfortable possibility. What if Earth experiences a major crisis? Humanity has survived many challenges: plagues, wars, environmental changes, economic upheavals. Our species is remarkably adaptable. Yet history demonstrates that no civilization remains guaranteed forever. Suppose Earth undergoes transformations so significant that the society which launched the generation ship no longer exists. The planet survives. Humanity survives. The original civilization disappears. Would that matter? For the descendants aboard the vessel, perhaps not immediately. Life continues. Children continue being born. The ship continues functioning. The mission continues. Yet symbolically, something profound has happened. The generation ship becomes older than its parent civilization. Imagine that for a moment. The vessel carrying humanity between stars has outlived the society that created it. Its traditions continue, its institutions continue, its educational systems continue. Generation after generation preserves the journey. Meanwhile, the civilization that began the mission exists only in historical records. The ship becomes a living artifact, a surviving piece of history. In some respects, this has happened before. Certain institutions have survived political systems. Universities outlived kingdoms. Religious traditions outlived empires. Cultural practices survived governments. Generation ships may represent the largest version of that pattern. A civilization carrying fragments of humanity's past into humanity's future. Of course, there is another possibility entirely. Earth may thrive beyond anything we currently imagine. Humanity may establish colonies throughout the solar system. Then beyond it, interstellar civilization may spread in multiple directions simultaneously. The generation ship becomes one branch among many. In this scenario, the vessel does not outlive civilization. It simply becomes one civilization among countless others. Interestingly, this outcome creates its own challenges. Imagine arriving at another star after 600 years, only to discover humanity reached it centuries earlier through faster technology developed after your departure. Science fiction authors have explored this idea for decades. A generation ship leaves Earth. The civilization left behind continues advancing. Eventually, superior technology allows later travelers to arrive first. The original mission reaches its destination only to discover someone already built a welcome center. The scenario sounds humorous. It highlights a genuine uncertainty. The future rarely unfolds exactly as expected. Generation ship residents would understand this reality better than most. Their society exists because people centuries earlier made plans for futures they could not fully predict. Some predictions proved accurate, others likely did not. Adaptation remains essential. There is also a deeper philosophical question hiding beneath all this. What exactly counts as civilization? Is civilization a place, a government, a culture, a population? The answer becomes surprisingly difficult once we start thinking about generation ships. Earth civilizations typically occupy territory. Generation ship civilizations occupy a vessel. Earth civilizations often define themselves geographically. Generation ship civilizations define themselves through continuity, through shared purpose, through collective survival. Perhaps civilization is less about location than we assume. Perhaps it's fundamentally about people, their relationships, their institutions, their stories, their ability to pass knowledge forward. If so, generation ships may represent civilization in one of its purest forms, a society stripped down to essentials, no continents, no borders, no competing nations, just a community preserving itself across time. That perspective changes how we view the voyage. The ship is not merely transporting civilization, the ship is civilization. Every generation contributes to its continuation. Every child born aboard becomes part of an unbroken chain connecting the launch to the arrival. The mission survives because the society survives. The society survives because people continue believing it should. Perhaps that's the real reason generation ships fascinate us. They force us to think on timescales larger than individual lifetimes, larger than political terms, larger than ordinary history. They ask whether human civilization can become something genuinely long-term, something measured not in decades, but centuries, not in generations, but many generations. And if the answer is yes, another question naturally follows. Suppose the ship survives. Suppose the population remains healthy. Suppose the culture endures. Suppose the destination finally appears ahead after centuries of travel. What happens then? For hundreds of years, the destination has existed only as an idea, a point of light in the darkness, a name in textbooks. A symbol carried forward through generations. Children learned about it in school, historians wrote about it, engineers planned for it, artists imagined it. Yet nobody had ever seen it with their own eyes. Not really. It remained distant, abstract, always somewhere ahead. Now imagine the moment that finally changes, not suddenly, not dramatically, not with triumphant music echoing through the corridors. The first signs would probably seem almost disappointingly ordinary. Astronomers aboard the ship notice subtle differences in their observations. A star that has remained unchanged for generations begins growing slightly brighter. Computer models confirm what everyone already suspects. The destination is no longer a distant target. It is becoming a place. For the first time in centuries, the end of the journey is visible. That realization alone might transform society. Think about it. Every person currently alive aboard the vessel grew up assuming the destination belonged to the distant future. Arrival was something descendants would experience, another generation's responsibility, another generation's dream. Then one day, that assumption disappears. The destination belongs to them, their generation, their lifetime, their future. History offers very few experiences comparable to such a moment. Perhaps the closest examples come from exploration. Imagine sailors crossing an ocean and finally spotting land after months at sea. Imagine early explorers reaching a destination that existed only on maps and speculation. Now multiply that feeling by centuries. Entire civilizations have waited for this moment. Entire civilizations have prepared for it, and suddenly it is real. The psychological impact could be enormous. Some people would feel excitement, others relief, some might feel anxiety. After all, certainty can be surprisingly comforting. For generations, everyone knew their role. Maintain the ship, continue the voyage, preserve civilization. Arrival changes everything. The future becomes uncertain again, and uncertainty, even positive uncertainty, can be unsettling. This reaction may sound strange. Surely everyone would celebrate. Surely everyone would be eager to reach the new world. Perhaps. Yet human beings rarely respond to major change in exactly the same way. Consider someone born aboard the vessel. Their parents were born aboard the vessel. Their grandparents were born aboard the vessel. The ship is not transportation. The ship is home. The ship is the only world they have ever known. Now imagine being told that soon, very soon, you may leave it forever. For some people, that sounds exciting. For others, it sounds terrifying. Earthborn listeners often assume planetary surfaces automatically seem preferable. That's because we evolved on planets. Future ship residents may possess different instincts. Open skies might feel unfamiliar. Uncontrolled weather might feel uncomfortable. Wild ecosystems might feel unpredictable. Remember, these individuals have spent their entire lives inside carefully managed environments. The temperature remains stable. The air remains controlled. Resources remain monitored. Outside the ship lies an environment nobody has personally experienced before. Even if extensive robotic surveys have already been conducted, uncertainty remains. And uncertainty makes human beings cautious. Imagine a child born aboard the vessel asking a simple question. Why should we leave? At first glance, the answer seems obvious. Because that was the mission. Because arrival was always the goal. Because humanity wanted a new home. Yet those answers may not satisfy everyone. After all, civilizations are not obligated to share the priorities of their ancestors. History demonstrates this repeatedly. Each generation inherits goals, some are preserved, others are modified. Still others are abandoned entirely. A generation ship reaching another star may face one of the most important decisions in its history, not whether it can settle a new world, whether it wants to. This possibility has fascinated researchers for decades. Science fiction often portrays arrival as the end of the story. In reality, it may be the beginning of a completely different debate. Some residents may advocate immediate settlement, others may prefer caution, still others may argue for remaining aboard the ship indefinitely. After all, if the vessel has successfully supported civilization for centuries, why abandon a proven system? The question becomes even more interesting if the destination proves less welcoming than expected. Perhaps the planet possesses a breathable atmosphere. Perhaps it doesn't. Perhaps gravity differs significantly from what residents are accustomed to. Perhaps local environmental conditions present unexpected challenges. No amount of planning eliminates every uncertainty. The first settlers would face genuine risks. The ship, meanwhile, remains familiar, safe, reliable, home. Human beings often prefer familiar difficulties over unfamiliar opportunities. It's one of our more predictable traits. Of course, there are also powerful arguments favouring settlement. A planetary surface offers possibilities that no spacecraft can fully replicate. Room to expand, natural resources, open environments, long-term growth. Entire generations aboard the vessel may have dreamed about such opportunities. The descendants of the original passengers might finally stand on a world their ancestors spent centuries trying to reach. Imagine that moment. A hatch opens. A group of settlers steps forward. For the first time in hundreds of years, human feet touch ground that is not Earth and not a spacecraft. The symbolism alone is extraordinary. Every birth aboard the vessel, every repair, every lesson taught in every classroom. Every challenge overcome during the voyage contributed to this moment. An entire civilization arrives together, not as explorers making a brief visit, as people searching for a future. History contains many famous journeys, migration across continents, crossings of oceans, settlements in distant lands. Yet all those journeys occurred within the same world. Generation ships introduced something fundamentally different, a migration between stars, the first truly interstellar civilization. The scale is difficult to comprehend. What makes the situation even more fascinating is that the arriving population may be very different from the one that departed. Not biologically transformed into another species, not radically altered, but shaped by centuries of unique experiences. Their culture evolved aboard the ship. Their traditions evolved aboard the ship. Their worldview evolved aboard the ship. They carry humanity's past. They also carry something entirely new. Imagine future archaeologists studying the society that eventually settles the destination. They would discover cultural influences from Earth, influences from centuries of shipboard life, new traditions created during the voyage. The resulting civilization becomes a blend of all three: Earth heritage, interstellar heritage, planetary heritage. A new chapter in human history begins. Interestingly, arrival may create unexpected emotional reactions. For some residents, the experience could feel deeply moving. Generations of stories suddenly become reality. Places that existed only in simulations become tangible. The future becomes visible. Others might feel grief, not because the mission failed, because something important is ending, the voyage itself. For centuries, the journey defined society. People built identities around it. Communities formed around it. Entire cultural traditions emerged because of it. Arrival changes those foundations. The civilization must reinvent itself once again. In many ways, reaching another star resembles graduation. Students spend years working toward a goal. Then one day they achieve it. The achievement feels wonderful. It also creates a new question. What happens next? Generation ships face the same challenge on a vastly larger scale. What happens after arrival? Do people disperse across the new world? Do they preserve the ship as a historical monument? Do they continue living aboard while gradually expanding outward? Different communities may choose different approaches. Some residents might eagerly embrace planetary life. Others may prefer remaining aboard. The vessel itself could continue functioning for generations after arrival, perhaps permanently. After all, by this point the ship is far more than a machine. It is a city, a homeland, a cultural treasure. Abandoning it entirely may seem unthinkable. Future settlers might preserve sections of the vessel much like modern societies preserve historical landmarks. Children growing up on the new world could visit the ancient ship and learn about the journey. They might walk through corridors where their ancestors once lived, study records from centuries earlier, explore museums containing artifacts from Earth. The ship becomes a bridge connecting past and future, a reminder of where their civilization came from. There is another intriguing possibility. Perhaps the destination is not the end at all. Imagine a society that successfully survives centuries of interstellar travel. What would stop them from doing it again? The knowledge exists. The experience exists. The culture understands long-term planning better than almost any civilization in history. A people capable of reaching one star may eventually reach others. The descendants of generation ship residents could become some of humanity's most experienced interstellar travelers. What began as a single mission gradually becomes a tradition, a way of life, a civilization comfortable with timescales that once seemed impossible. In that sense, the first arrival may not represent the conclusion of humanity's expansion. It may represent the moment expansion truly begins, the first successful proof that human civilization can survive between stars, the first demonstration that distance alone cannot stop us. Yet perhaps the most remarkable aspect of arrival is how ordinary much of it may feel. People will still wake up, eat breakfast, go to work, raise children, build communities. Life continues. History often focuses on dramatic moments. The reality of civilization usually consists of ordinary days strung together across time. The same will likely be true here. The great interstellar voyage eventually becomes history. The settlers become residents. The future becomes the present. And somewhere, perhaps generations later, children will grow up on the new world listening to stories about the ship. Stories about the long journey through darkness. Stories about Earth. Stories about the civilization that spent centuries crossing the space between stars. To them, those stories may feel almost mythical, much as Earth once began to feel mythical aboard the vessel itself. If a generation ship can survive for centuries, if a civilization can endure between stars, what does that reveal about humanity itself? Many years from now, perhaps centuries after departure, a child might ask a simple question. Not a technical question, not an engineering question, not a question about engines, agriculture, radiation shielding or navigation. Something much simpler. Why did they leave Earth? At first, the answer seems obvious. They left because they wanted to reach another star. They left because humanity was curious. They left because exploration has always been part of our story. Yet the longer we think about that answer, the more interesting it becomes. Because throughout this journey, we've talked about ships, we've talked about ecosystems, we've talked about technology, psychology, culture, genetics, and survival. But underneath all those subjects lies a deeper question. What exactly is a generation ship trying to preserve? The ship, the people, or something else entirely? As strange as it sounds, the answer may determine whether the mission ultimately succeeds. When most people imagine a generation ship, they focus on the vessel itself, the enormous structure crossing the darkness, the rotating habitats, the farms, the machinery, the protective shielding. the artificial world carrying humanity between stars. It is an impressive image, a city moving through interstellar space, a triumph of engineering. Yet history suggests something important. Machines rarely last forever. Even extraordinary machines, the oldest ships on Earth eventually disappeared, the oldest aircraft eventually retired, the oldest vehicles eventually became museum pieces, technology ages, materials wear down, components fail. Generation ships would certainly survive far longer than any vehicle humanity has ever built, but eventually even they would face limits. A vessel surviving for 500 years would be remarkable. A vessel surviving for 1,000 years would be astonishing. A vessel surviving for 10,000 years would seem almost miraculous. Yet eventually every physical object encounters the same reality. Nothing material lasts forever, at least not without continuous intervention. And that observation leads us somewhere unexpected. Perhaps the most important thing aboard the ship was never the ship. Think about a city. What makes a city survive? The buildings? Not necessarily. Cities are rebuilt constantly. Roads are replaced. Structures are demolished. New neighbourhoods appear. Old neighbourhoods disappear. Yet we still consider the city continuous. London today is not physically identical to London centuries ago. Almost every part has changed. The people changed. The architecture changed, the technology changed, yet something persisted, a continuity larger than any individual building. Civilizations often work that way. The physical components matter, the continuity matters more. Generation ships may ultimately follow the same pattern. The vessel launched from Earth might gradually transform during the voyage, systems replaced, structures redesigned, technology upgraded, generation after generation modifying the world around them. Eventually, very little of the original vessel may remain, yet the society survives, the mission survives, the continuity survives. At that point, what exactly is the ship? Is it still the original vessel, or something new? Philosophers have debated similar questions for thousands of years. One famous thought experiment involves a ship whose planks are replaced one by one until none of the original material remains. Is it still the same ship? There is no universally accepted answer. Generation ships may become the largest version of that puzzle ever attempted. After centuries of repairs and modifications, the arriving vessel might share very little physical material with the vessel that departed, and yet everyone would still call it the same ship. Because continuity often matters more than components. The same principle applies to civilization. A generation ship may preserve institutions for centuries, schools, governments, cultural traditions, community structures. Yet those things will also change. Languages evolve, values evolve, customs evolve, new ideas appear, old ideas disappear. Future residents will not think exactly like the founders, nor should they. Healthy civilizations adapt. Imagine a person from 600 years ago visiting modern society. Much would seem unfamiliar. Technology, politics, daily life, social norms, and yet they would still recognize humanity. The details changed, the species remained. Generation ships would experience similar transformations. The descendants arriving at another star may feel very different from the people who departed Earth. Different traditions, different assumptions, different cultural perspectives, still human, still connected, still part of the same story. This realization reveals something fascinating. The mission is not actually preserving a specific civilization, it is preserving civilization itself. The distinction is subtle but important. Many people imagine generation ships as time capsules, a way of freezing humanity exactly as it existed at launch. That approach would almost certainly fail. Nothing remains frozen for centuries. Not cultures, not technologies, not societies. The more realistic goal is continuity through change. Allowing humanity to evolve while ensuring it continues. History repeatedly demonstrates the power of this approach. Civilizations survive not because they resist change, they survive because they adapt to it. The Roman Empire changed repeatedly before eventually transforming into other societies. Languages evolve continuously. Scientific knowledge expands. Cultures absorb new influences. Continuity often emerges through adaptation rather than preservation. Generation ships may simply accelerate our awareness of that reality. Then there is humanity itself, the species, the larger story. Suppose a generation ship survives for centuries. Suppose it reaches another star. Suppose its descendants establish a thriving civilization. What exactly survived? The answer depends on perspective. From one point of view, humanity survived. People remained alive, families continued, communities endured. From another perspective, something else survived. An idea. The idea that humanity belongs among the stars. The idea that our story does not end on one planet. The idea that curiosity remains worth pursuing even when the rewards lie centuries in the future. Ideas often outlive civilizations. They certainly outlive individuals. Consider how many concepts have survived through history. Mathematics survived countless empires. Astronomy survived countless governments. The desire to explore survived countless generations. People changed. The ideas continued. Generation ships may ultimately exist because of one particular idea. That the future matters, not merely our own future, the future of people we will never meet. This may be the most extraordinary aspect of the entire concept. Think about what a generation ship requires. Thousands of individuals contributing to a project whose ultimate success belongs to distant descendants. The founders will never arrive. Many generations will never arrive, yet they continue anyway. That level of long-term thinking is rare. History usually rewards shorter timescales. Political terms, business quarters, individual careers. Generation ships demand something different. They demand faith in future people, not blind faith, practical faith. The belief that future generations deserve opportunities we ourselves may never experience. In many ways, that belief already exists around us. People plant trees whose shade they will never enjoy. Scientists conduct research whose applications may emerge decades later. Engineers build infrastructure intended to serve future communities. Parents make sacrifices for children. Children eventually do the same. Generation ships simply stretch that principle across the stars. Perhaps that is why the concept feels simultaneously inspiring and intimidating. It asks us to think beyond ourselves, beyond our lifetimes, beyond our immediate concerns, not because those concerns are unimportant. Because humanity's story may be larger than any individual chapter within it, and that brings us back to the question, would the ship survive longer than humanity? The answer depends entirely on what we mean by humanity. If humanity means a particular government, probably not. Governments change. If humanity means a particular culture, probably not. Cultures evolve. If humanity means a particular technology, certainly not. Technology transforms constantly. But if humanity means something broader, a continuous chain of people passing knowledge forward, raising children, building communities, solving problems, exploring the unknown, then perhaps the ship never needed to outlive humanity at all. Perhaps the ship was simply one expression of humanity, one chapter in a much longer story, a story that began long before the vessel launched, and may continue long after the vessel arrives. Imagine the descendants standing beneath an alien sky, centuries after departure. Children playing in places their ancestors never saw, communities growing, civilization expanding. The generation ship preserved more than lives. It preserved possibility, the opportunity for humanity to continue. And maybe that has been the real mission all along. Not merely reaching another star, not merely surviving deep space, not merely building a vessel capable of crossing impossible distances. The deeper challenge was proving that human civilization can think beyond individual lifetimes, that people can work toward futures they will never personally witness, that curiosity can survive centuries, that cooperation can survive centuries, that hope can survive centuries. The ship carries all those things through the darkness. Eventually it reaches another world. Eventually its journey ends, or perhaps in some ways it doesn't. Because somewhere beyond that destination, other stars still wait, other questions still wait, other futures still wait. And if a generation ship teaches us anything, it may be this. The most durable thing humanity has ever created is not a machine, not a building, not a civilization. It is the ability to imagine a future beyond the horizon and then spend generations moving toward it. Whether that horizon lies across an ocean, beyond a mountain range, on another planet, or among the stars themselves, the pattern remains surprisingly familiar. People look into the distance. People wonder what lies beyond. People begin the journey. Others continue it. Others continue it after them. And somewhere, far ahead, descendants eventually arrive at places their ancestors could only imagine, which means that even after the generation ship finally reaches another star, the story it represents may continue far longer than the vessel itself. Because humanity's greatest survival trait was never technology alone. It was always the willingness to keep going,